Alright, hello guys. So recently I've been browsing around the IGCSE Discord group and I noticed a lot of people, they're asking for a video covering the entire IGCSE syllabus. So in this video, that's exactly what I'm going to do. Alright, I'm just going to cover all of these topics here. So if we just look quickly, we've got a variable declaration, and yeah, let me just zoom in a little bit. Okay, we've got a variable declaration, we've also got constants. Alright, we're looking at the 5 different primitive data types. Yeah, we're also going to look input output. We're going to look at the arithmetic and logical operators. We're also going to look at all of the built-in modules. Now some of these like int, I think I've seen people post mark schemes that have this. However, in the new syllabus they actually don't. So I think, yeah, probably this one they shouldn't ask. Right, then we're also going to look at selection. So if, well, yeah, if else, also case. Right, we're then going to look at the 3 different loops. So we've got the count controlled for loop, we've got the preconditional while, or while do, and then yeah, we've got the post conditional repeat until loop. Right, then I know this is something that people struggle with, so then we're going to look at arrays, in particular 1D arrays. Right, and then when we've kind of let's say become more confident with that, then we'll move on to these 2D arrays here. Right, we'll also look at how to write our own custom modules, so write our own functions, write our own procedures, and then finally we'll just look at files. Alright, and I guess, yeah, in particular, we'll also look at linearSearch and also bubbleSort. Right, so these would be 2 functions, function procedures that, yeah, you're going to need to know, how to code. Alright, so yeah, I think without any further ado, let's just get started. So I'm just going to comment all this just as a kind of reference for myself, and hopefully, hopefully this video should take about an hour. Alright, so we'll try and go quickly. Right, so the first one then, we'll just look at how to declare all of the 5 different primitive data types. So the first one we've got, let's go maybe integer. Let's call it age, for example, and we'll say this is an integer, and I'm just going to say me. So here my age is going to be 28. Right, let's also then declare maybe name. Let's go string. Now, right, I'm actually not going to use my real name, so let's just go maybe like Pseudocode Pro. So yeah, just the name of the website. Now, if we look, okay, a string, that's going to have to be in double quotes, and basically a string is going to be like 0 or more characters. So we could have just an empty string like this. Or of course, we can have many characters. Right, let's go, for example, gender. And here, let's say gender is going to be char. Now, I often see people asking, what should gender be? Should it be a character? Should it be a boolean? I think here, probably you can use either, right? So you could say like is male, and that can be true or false. Yeah, we could also go gender like this, and let's just say M, right, for male. Now notice a character is only going to be 1 character. So for example, if we type male like this, if we just run this, yeah, it's going to say invalid character male. Okay, characters should be of length 1. So yeah, let's just set that to 1. Alright, and then yeah, here we're not going to get any error. Right, let's look at the next one. Let's go maybe, maybe height. And let's say this, yeah, okay, height is fine. Right, let's say this can then be a real. So a real, this can just be decimal. So let's go here and we'll say height is maybe 185.5. Because basically, if we say an integer, an integer can only be a whole number, right? So you're like 1, 2, 3. Whereas yeah, height can be basically like a decimal number, right? Any number. It's going to be continuous. Alright, and then let's say we also want to have boolean. So yeah, I don't know, maybe like is, maybe is taking exam, and let's say that's going to be boolean. And then for me, actually, yeah, I guess kind of luckily, right, I'm actually not taking the exam, so let's set that to false. Now, a boolean, probably right, but it can only be either true or false, right, so just 2 values. And note, of course, when we assign values, right, obviously we're just using this kind of double arrow. Now, the site will actually work where you can have a single single hyphen like this, right? You can also have as many as you want. You can also just directly copy and paste from the mark scheme. So I think the mark scheme they're using some like Unicode arrow, and yeah, that character should also work. Right, however, for me, I'm just going to use this. Yeah, just since I can type it on the keyboard. All right, and then I mean we can just look at how to output this. So to output is pretty easy. Let's just go output, and for example here, let's go output name. And then yeah, if I just move this across, well, you can see it just outputs Pseudocode Pro here. Now, of course, we could change this to like age, gender, height, right? Yeah, we can output all of them. But I think what I'm going to do, I'm actually going to output sort of both of them on one line. So we could then go age, and let's go gender like this. And now you see it says, yes, Pseudocode Pro 28 and then M. However, probably what we want is, maybe we want to make a sentence. So basically we can just add some strings here, or add some text. Let's say maybe is, and then for example we'll go comma. So we want to say like Pseudocode Pro is 28 years old and is M, right, male. Right, so I think after here we then want to go years old. Then let's say, yeah, and is, and that should be male. Yeah, okay, alright, so this works pretty well. And of course, you can also extend it to include these if you want. Right, so let's say we also want a constant. Now, if we think, well, a variable, basically we can change it. So let's just copy this again. And for example, now let's go name, and we'll just reassign it. Let's say, for example, I don't know, like Fred, and let's say age. And then here, maybe this can be, yeah, 18. And let's go gender. And in fact, I think probably I'll just change this to be maybe a woman. So yeah, just so we change all, like maybe Betty or something. And then yeah, so here of course, we're just reassigning these values, and then just like printing out the data again, or yeah, outputting the data again. Now, I mean, we won't do it at the moment, but because here we've actually got this repeated code, right here this output is the same, and also here this output is the same, then this would actually be a good place to make our own custom procedure. Yeah, however, we won't do it yet. Right, although that can be a challenge, for you later. Try and make a procedure that takes in 3 parameters, right? Name, age, gender, and then just outputs a sentence like this. Right, and so let's say we also want to look at output. Input. Let's actually delete this, and I think instead of actually kind of assigning them directly, let's actually just let's ask them to input. So right, let's say enter your name. And then we'll just go input name. So basically this output will display the output message, and then it will kind of pop up this prompt, and yeah, then it's gonna, well, whatever they type in will be stored in this in this name variable. Right, I'm just going to copy this, and oops, yeah, I ran it by mistake. Right, then let's say enter your age, and let's say here that's going to be age, right, and you notice here that the way input works is that, well, basically it will convert what they input to be, of this particular data type. So here, because age is an integer, well then it will try to convert this age into an integer. Now, if, for example, they type in ABC, well, ABC will be an invalid integer, right? Therefore, that will actually, give you an error. And then let's say here again, gender. Right, let's say enter your gender. Right, so let's say, I don't know, let's say Paul, let's say he is 25, and let's say he's male. And then, yeah, okay, so we see this works. Right, now I think just the final thing of this, right, sometimes we might also have constants, and to be honest, I'm actually going to put a constant at the top, because, yeah, usually you would declare all of the constants at the top, just so it's kind of easy to see them. Now, like we said, a variable, we can assign them a value, and then, reassign them a new value, but a constant, we actually won't be able to do that. So, I mean, for constants, we actually can use equals. I think for A level they use equals. I think for IG they actually do just use the assignment arrow. And okay, by the way, just so I think I did forget. Right here, when you first load the website, it will tell you like what syllabus you want to choose. I mean, if you're doing IG, make sure you've chosen the IG syllabus. You can also click here, just to again choose IG, because basically that will just give you the correct code suggestions. It will give you the correct version of the modules, the correct kind of syntax, for IG. So anyway, let's say here, I mean, pi, I'm not sure exactly, but let's say 3.14. I'm not really sure the rest of it. And then for example here, let's just go output pi, and if we just run, in fact, let me actually just comment this, because yes, it's kind of a little bit annoying. Right, so here we see pi like this. Now let's say we then try and reassign it, I don't know, is it 2.71? I think that's going to be E instead. And then if we just go output pi, and I'm actually just going to delete all this. Right, I mean, we should get an error. And again, I think I mentioned this before, it's not the best error message, so I will actually kind of fix this at some point. But if we see here where it says line 38, basically it's saying, well, we can't, we can't reassign a value to a constant. I mean, that's what this error message, should be saying. Because again, once a constant is set, well, you can't change it. Right, okay, so I mean, hopefully that makes sense, how we do variables, constants, the 5 different primitives. So again, that's going to be integer, string, right, char, character, real, and then boolean. And then also how we do input and output. Right, so the next one we want to do are arithmetic and logical operators. So let me just, I mean, in fact, well, let's just kind of output them directly. I mean, or we could, okay, all right, let's actually ask them to input. So let's say maybe A, let's also say B, right, these are going to be integers. And note, right, if we have 2 variables of the same type, we can actually declare them on the same line like this, okay, just using a comma. And then let's say, output, we'll go enter, value for A. Then we'll just go, then we'll just go input A. Alright, I'm just going to copy this again. Let's say enter value for B. Right, let's just go, input B. Right, so here then, just the simple mathematical operators. Well, we're just going to have plus. Right, I've ran it again by mistake. Right, I think that should be all of them, 6. Or maybe 7. Right, so we're going to have plus, then we're going to have minus. Right, then we've got this, which is multiply. Right, we've got divide. Right, this next one, this is going to be power. Now, I think, I mean, some people do use this to represent power. However, I do think that in the syllabus they actually use this one, right? They use the caret. Alright, and then I think there should just be 2 more. So this one is actually going to be a function, right? This is going to be div. And then here we're just going to want to separate like this. Now, if we actually look here at the kind of code suggestion, or the I guess kind of module signature, right, function signature, basically it's going to return the quotient of A divided by B, right, with the fractional part discarded. And I mean, this description literally comes straight from the syllabus. So I think in kind of an easy way to think of this is like if you have pizza. Now here, let's say we've got 10 slices of pizza, and we've got 3 people. Well, this means that each person will get 3 slices of pizza, right? Likewise, if we had 12, and let's say we have 5 people, well, here each person is going to get 2 slices of pizza, right? But then there's going to be 2 slices remaining. So the remaining is then going to be this mod part, and again, this is going to be a function. And I mean, if we just look at this again, here it says returns the remainder of identifier 1, well, let's call that A, right, divided by identifier 2, right, B. So again, thinking of pizza, well, if we have 10 slices of pizza and 3 people, well, then each person is going to get 3 slices, right, but then there's going to be 1 remaining, well, 1 left over. So I mean, that's just what this is going to do. But anyway, let's just run these. So let's say maybe 12, and let's, I mean, okay, let's go 5, right, although this is going to be huge for one of these. Right, so I guess the first one, I mean, yeah, so 12 plus 5, right, 12 minus 5, yeah, 12 multiplied by 5, right, divided by, I mean, this one's obviously huge, so 12 to the power of 5, and then, yeah, here, well, div, right, each person is going to get 2 slices of pizza, and then again, 12 mod 5, right, there's also going to be 2 slices remaining. Right, so I mean, yeah, I think hopefully that makes sense. Right, let's just, yeah, well, I think let's just delete all of those. Right, now let's just go, yeah, all right, let's also declare them. All right, let's go A and B. Or in fact, we could do, yeah, let's call it like did revise. And then we'll also call it, maybe, I don't know, yeah, did past papers. I'm just trying to think of 2 conditions. Right, so let's say here we can say maybe did revise can be true, but then we'll say did past papers, right, this will be false. So here then what we're going to do, we're just going to try or. So if we go did revise or did past papers, right, well, if we think back to the Boolean logic, and hopefully you've done this, right, then you should know that this will be true. Because if we have, well, true or false, for or to be true, then only one of them has to be true. Now if we do the next, in fact, all right, let me just copy this. Right, let's try and. So, well, did revise and did past papers. Okay, this should be false, because, well, here and means, both of them have to be true. And then I think just the next one, well, the next one is just going to be not. Right, so not will just kind of invert them, right? So not true will become false, and not false will become true. And then yeah, if we run this, well, did revise or did past papers, yeah, that's true, because, well, true or false. The next one, well, true and false, right? That's going to be false. And then here we've got not true, so not true becomes false. Right, so yeah, I think they're all working. And then probably, yeah, I probably should have also said the comparison operators as well. So let's also have a look at this. And in fact, I'm just going to kind of undo. Because, yeah, for these we're going to need integers. Right, let me just delete that. So the first one then, let's just go greater than. And again, let's just copy that. Okay, that's a little bit annoying. Right, okay, then, well, then, yeah, let's just go greater than or equal to. Right, then let's do less than. Let's do less than or equal to. I guess then we'll do equal to, and then let's go not equal to, like this. Right, so this should be all of them. So here, let's just say A can be 5 and B can be 3. Now, if we see, well, 5 is bigger than 3, yeah, alright, 5 is greater than or equal to 3, right, also true. I mean, less than or equal to, right, they're going to be false. Of course, what equal to is going to be false, right, but then not equal to is going to be true. And of course, we can use different values. Let's go 5 and 5. And then, of course, here we see, yeah, equal to is going to be true. And yeah, not equal is going to be false. Right, now, I mean, we can use this for integers, right? However, we can also use this for, strings, for characters as well. So let's say maybe, I mean, yeah, let's make this a string. Or in fact, yeah, maybe let's make it a character. And right here, I'm just going to assign them just so we can see quickly. Right, let's say A is just going to be the character A. And then, right, Z here is going to be the character Z. Now, I think for IG, you don't really need to know these as much because, well, there's not as many string functions, or there's not as many string questions, compared to A level. But if we think of, well, I mean, hopefully you remember ASCII, right? I think the American Standard Character, I don't know, maybe interchange or something. Yeah, I'm not really sure. But basically, it's just a character set, right? And if we remember, standard ASCII can represent 128 different characters, right? Because it's just using, well, basically it's just using 7 bits. And then if we have extended ASCII, well, extended ASCII is just using 8 bits, right? Which is going to be 256 characters. So basically the ASCII values, let's say here for big A, well, big A is going to be 65. Right, then we say big Z. Well, basically we just have to plus 25. And this might confuse people, and it also confused me, because I thought, well, there's 26 characters in the alphabet, so if A is 65, I would have thought we would then plus 26. But for example, if you think about this, let's say we've got A, right, then we've got B, then we've got C. So here, well, if we say A is character 0, right, or we can say 65, right, B is going to be 66, C is then 67. So even though we see, well, C is character 3 in the alphabet, right, it's only 65 plus 2. So yeah, even though it's the third character, we only plus 2. Likewise for Z, right, Z is the 26th character, but we plus 25. And I guess the reason for that is because, well, you can consider A as being like character 0 effectively. Yeah, or 65, and we kind of consider that as being the 0th character. Right, and then if we look at the next ones, let's say A is then going to be 97. Right, likewise we just plus 25, so that's going to be 122. And then we can also say 0 here. This is going to be 48. And then likewise here, well, here we just plus 9, right, so that's going to be 57. So when we actually do these comparisons, well, what it's doing is actually just comparing these numbers. So if we think the first one, well, because we're saying, right, small a and small z, in fact, sorry, let's make that b. Right, I mean, yeah, all right, okay, let's just go ahead and make all of these z actually, just to make it kind of clearer. Right, okay. So yeah, I mean the first one, this is saying, well, is 97 bigger than 122? And of course this is going to be false. So I mean let's just go ahead and run these. And yeah, I guess if you pause it, these well, they should all make sense, right? Equal, well, it's not equal. So yeah, of course this not equal is going to be true. Alright, so yeah, I think that's all of them, right? So now then, if we talk about the built-in modules, and I mean you see here there's only, well, let's say sort of 5, because again this int is probably not included. Yeah, or no, okay, sorry, there's 7, right? So yeah, probably 6, if int is not included. And in fact, yeah, let me just copy them just so I don't forget. Alright, so if we look at the first one, well, random, and again, that's a little bit annoying. Okay, there we go. Right, it's going to return a random number with the range 0 to 1. Alright, and then, well, here it says use, rand if you're doing A level. But yeah, I mean, for IG, it's going to be this. So, I mean, if we just run this, again, yeah, we just get a number between 0 and 1 like this. Of course, it's going to be different every time. Now, often the question will be, well, how do we get a random number from, let's say, 0 to 20? Well, if we want 0 to 20, then yeah, we can just go like this. And yeah, okay, so obviously here you see we get a number. Now, let's say we want a number from 1 to 20. Now, what we can actually do, basically, if we wrap this in brackets, and then, for example, we can just go plus 1, right? So this will get a number from 0 to 20, right? Then if we go plus 1, now the problem is this will actually be, well, this will be 1 to 21. So, of course, we can make this, well, 19. Right, so again, this will get a number between 0 and 19. Then if we just plus 1, well, then that will just move it from, 0 to 19, right, and then kind of shift it, until 1 to 20. And yeah, we can see that works. And for example, let's say we wanted a number between like 50 and 60. So here we can go 50. And then I guess, well, we want a range of 10. Right, because yeah, this will be this will get between 0 and 10, and then yeah, plus 50. And then yeah, so you see here, right, it's just 50 to 60. And if we also want to round it, so I guess this kind of moves us on quite nicely to the next one. We can then just go round, and I'm just going to wrap the whole thing inside here. And then here it's going to tell us, well, yeah, the number of digits to round to. So if we only want a whole number, well then we can just use 0, right? So this will basically have like 0 decimal places. And yeah, okay, you see we just get 60, 59, okay, like this. Now I'm just going to make it a bit more simple, right? Because yeah, maybe it's a bit complex, we've got a kind of function inside a function. But right, let's just go round. Let's say like 1.2. Yeah, something like this. Now let's say here we just round this one to 0. Right, and I'll just paste these a few times. Let's round this to 1, round this to 2, right, 3, 4. And then yeah, hopefully you can see obviously what this is doing, right? Just rounding to 1 decimal place, right? Rounding to 2 decimal places, yeah, etc. Now, this is a little bit different to the int because, for example, here, well, let's just delete some of these. Like, let's say here we have, I don't know, I mean, maybe like 0. And let's say, for example, 0.5. Now, if we think round, well, round, if we round 0.5 in maths, right, that's going to go to 1. Likewise, of course, we can have like 0.999. However, if we use int, and let's just, yeah, so actually int only needs 1 parameter. Well, what int is going to do is basically it's just going to delete all of the kind of decimal part. So in this case, well, int of 0.999, right, it's just going to delete all of those decimals, just so we get 0. And yeah, we can see this here. Now, I mean, in maths, right, this is also equal to the, I think it's called the floor function in maths. So yeah, floor always just means kind of like round down, right? I think always round down. But again, right, this is just not included in the IG syllabus, although I have seen some people post mark schemes where they have this. I'm not sure, maybe those mark schemes were AS mark schemes that they were posting in the IG group. Or yeah, maybe it was the old syllabus or something. Alright, so I mean, hopefully they won't ask you about int, because again, it's not in the syllabus. Right, so if we look at the next one, substring. Right, so let's say, alright, so let's just go pseudocode. Let's say pro. Right, so let's say the first one, we just want to extract this pseudo. So if we look at this, well, the first parameter is just the string. Right, the next one, it says the starting position of the substring. So here we want to start from character 1. And then what we want to do, well, this is the length of the substring. So if we want pseudo, well, we see this is going to be 6 characters, right? So yeah, P-S-E-U-D-O. Okay, that's 6 characters. So this should output pseudo. Yeah, okay. Now, let's say here, if we now want to output code. Well, code here, if we look, the first character, I mean, let's just count these, right? So P is 1, S is 2, E is 3, right? U is 4, D is 5, O is 6, right? So C is going to be character 7. And then here we just want to get 4 characters, right? Because, yeah, we just want code, which is 4 characters. Alright. And then, for example, likewise, if we want pro, I guess pro, is that going to be 11? And then it's going to be 3. Yeah, okay. And I think, alright, let's look at how to do a loop now. Okay, well, no, in fact, alright, let's look at how to do a loop later. Because sometimes you might want to loop through and, output every single character. So yeah, we'll look at how to do that. And in fact, let me just write a, substring to output characters, just so I don't forget that. Right, and then I guess, we could sort of directly just use this UCASE here. So obviously we can wrap functions inside functions. So UCASE, well, this will take either a character or a string, then just convert it to uppercase. Likewise, we can then use LCASE. And of course, yeah, that's just going to convert that to lowercase. So yeah, if we just run this, well, here you see, yes, pseudo goes to uppercase, right, code goes to lowercase. And well, this pro, we've not changed. And of course, again, if that's a little bit complex, we can just have, let's say like ABC, right, and then this is going to become lowercase. But if we think about this, well, this substring is just going to return a string. So effectively, like, this whole substring is just going to be equal to this pseudo. So effectively, it's the same as just doing this, right? Because again, that substring function will just return, the string pseudo. But so here it's kind of more simple, right? We can just see it. Right, then I guess the last one, length. This is quite easy. It will just kind of count how many characters. How many characters are in the string. So here, the length is just going to be 6, right? Because again, there's 6 characters here in this string. So hopefully those make sense. Obviously, have a practice with them. Make sure you remember them, right? Make sure you understand. Because the thing that's a little bit annoying is that, for A level, they actually give you a list of all the functions. And I think for A level, maybe there's like, maybe 15 or, possibly 20. For IG, there's, let's say probably 6, if we delete this int. But it's kind of annoying because they actually don't give you the list, right? So you do have to remember them. And you have to remember the parameters. So, random, this has no parameters. Round, this is going to take 2 parameters, so the number to round and then how many decimal, how many digits or how many decimal places. Substring, this takes the string, then it takes the starting position, right, then the number of characters. Right, length, this just takes 1, right, the length, the string that you're counting the length of. And likewise uppercase, UCASE, LCASE, right, they also only take 1. Which again is just the string that you're, the string or character that you're converting case of. Right, okay, so next then if we look at selection, right, let's say we want to check if something is even or odd. And alright, maybe let's try something a little bit more simple first. So again, let's go to declare, let's say maybe did pass papers, or maybe did homework. Right, let's make this a boolean. Let's say did homework is going to be true. And let's go if, so we say if did homework, right, then we have to say then. And I don't know, let's say like, good student or something. Right, let's go else. I think that's fine. Right, else, let's just output, I don't know, bad student. Something simple. Now the thing is, right here, when we have an if, basically, this condition just has to evaluate to a Boolean value, right? So it has to evaluate either to true or false. Now the thing is, this did homework, this is true. So effectively this is saying, if did homework is true, right, then output this. Now if we want to be more explicit, we can actually kind of, explicitly say equals true. Which, to be honest, in the exam, I would recommend you do this. So always just use the equals true or equals false, just to explicitly say like what you're checking. But if we just run this, you see it's going to say good student. Let's say maybe I don't know, like predicted, let's say A. I don't know, let's say predicted C. If they don't do their homework, maybe that's optimistic. Right, let's also say did pass papers. Alright, so here we're actually going to have multiple conditions. Now, if you're familiar with other programming languages, you can have like if, then else if, else if, else if. However, Pseudocode doesn't support else if. Alright, we actually need nested ifs. So what we're going to do, we're then just going to go if. And let's say here we will go right, okay, let's say, right, let's go did homework and did pass papers. And for example here, maybe we can go A star, right, if they did both. Right, let's go here, we'll say if did homework, right, did homework equals true, alright, or did pass papers. Right, I guess if they did one of them, right, maybe we can go B. Right, then we're just going to go else, and let's remember the end if. And then here we can probably just go, predicted. And I think the spelling is bad, but never mind. Maybe predicted, or C, or maybe U. I don't know, let's say U, right, fail. Right, so what this is doing then is saying, well, if they did homework, right, and they did the past papers, then they'll be predicted A star. All right, if they did homework or they did the past papers, right, then they're going to be predicted B. And well, else if they did neither of them, right, then they're going to be predicted U. And let's just also assign this here. So let's try first. So this should say A. Yeah, okay, well, yeah, A star. Right, let's set this one to false. Yeah, that's going to be B. And of course, we can also change this to false, make this one true. Right, that's also going to be the same. And then, yeah, here if we go false, well, now I should say U. Yeah, okay. Right, so hopefully this makes sense. The thing with if statements is that, well, it can only do one of them. Right, so if it goes into this first condition, right, then it's only going to do this, then it's going to stop. However, if this condition is false, well, then it's going to go to this else block. Right, of course, then it's going to check this condition. Well, if this condition is true, it's going to do this. If this condition is false, well, then it's going to go to this else block, and do this. Like, let's say if we remove this else, now here, if we got false and false, well, this will actually output nothing, right? Because, this condition is going to be true and this condition is going to be true. And, there's no else here. Yeah, so we just see nothing. Right, but anyway, let's look at the other examples we want. So we want to check if a number is even or odd. And I mean, this is a common task. I think for IG, maybe they don't ask it as much. I mean, for A level, it's, sort of semi-common. So let's just say number. And let's say this is going to be an integer, right? And we'll also ask them for input. Right, let's delete all this, just so we can practice again. Well, let's say enter a number. And then hopefully you can remember how to input. Right, and then if we think, well, yeah, we need to think how we can check if a number is even or odd. Now, we can actually use modulus for this. So if we go mod, right, this is going to be num, and then we, well, mod by 2. So I'll let you think about this, right? If we have an even number, let's say like 4, so if we do 4 mod 2, or, 6, 8, 10, right, mod 2, what's that going to equal? Right, and then likewise, if we have an odd number, let's say, well, like, sort of, well, 1, 3, 5, 7, for example, 5 mod 2, right, well, that's going to equal 1. Whereas if we have an even number, mod 2 is going to equal 0. So yeah, we can just check, right, if sort of, well, yeah, mod, or, sort of num mod 2 equals 0. Right, then let's go output, and we'll just say num, and let's say is even. Right, then we're just going to go else, and let's go num, and then, right, is odd. And then again, make sure we just remember to have the end if. Right, let's try 6. Yeah, 6 is even. Right, let's say 7, and alright, 7 is odd. Okay, so yeah, that works. Right, now let's try and make a simple program where we basically ask the user to enter 2 numbers. Right, then we ask them to enter an operator. Right, and then we actually perform that calculation. So I think I'll actually do it just here, just with, well, plus and minus. Right, so let's go maybe num1, let's also go num2. Let's say enter number 1. Right, yeah, I'm going to delete this if. Right, let's go, yeah, input number 1. Right, let's copy this. Yeah, I think I've done that so many times. Right, and then input number 2. Now, right, okay, let's also go operator as well, declare, let's say op, right, operator. That can be a character because, well, it's just one character. Right, let's go, okay, not declare. In fact, yeah, let me just paste it again. Right, let's say enter operator. And, we can give them a list, let's say, like, right, let's also say mod and div. And I guess, yeah, we can also have the hat, the hat or the carrot. Right, so what we can then do, basically we just need a load of if statements. However, I think I'm only going to do 2 because, well, this is going to get super nested. Right, so let's say here then, and yeah, this is just going to be input into op. Let's say if op, and we're going to check that is equal to the plus. Right, then what we'll do, I mean, we can actually output this as a message. So let's say, like basically we want to output the whole calculation. So we want to output, you know, num1 plus num2 equals, right, and then the answer. So let's go num1, right, and then, in fact, yeah, let's make that a string because we'll have a space. Right, then let's go num2. Right, then let's just here go equals, and then, I mean, we can put in brackets if we want, right, although we don't really need it. Right, I mean, this should work. Let's just go end if just to check this works. Right, let's go 5, let's go 3, and yeah, let's go plus. Yeah, okay, so we see this works. Now, right, I'm just going to copy this. So then what we're going to have the else, and then inside the else we're going to have if. And let's go here, if op equals, yeah, minus. Right, then we're going to do this, then we're going to do this. Again, we're going to get end if. Right, and let's just try this again. Let's try maybe 9, let's try 4, and we'll try minus. Okay, so yeah, let's just remember to change these. Right, 9 minus, oops, okay, 4, and then minus, yeah, and then we see this works. Now, you know, I mean, you could continue this if you want. For example, you can go else, right, and then, yeah, if, and then, well, another else. You know, do it for all of them. But you can see this is getting quite nested, or it's getting quite complex. So there's probably actually a better solution for this. And that's going to be the case statement here. Alright, so let's look at how we can do case then. So if we just write here, well, we go case of, then we need the variable that we're checking. So in this case, that's going to be the operator, right? And then here we just need to remember this end case. Now here we just output the different conditions, or yeah, just write the different conditions. So the first one's going to be plus, right? Then we just write the colon, right? And then basically just paste it. And then yeah, the next one, well, I'm just going to copy it a few times. Right, so the next one then, this is going to be minus, this can be multiply, right, this can be this, divide. And then, yeah, of course, just change here. And then, right, this is then going to be minus, this is going to be multiply, right, that's going to be divide. And, you know, if you want, you can also do these three. However, I think for me, this is okay. Right, I'm then also just going to go otherwise, so this means invalid. And yeah, to be honest, you would also want to implement these yourself, you know. Right, let's go output, let's say invalid, yeah, maybe invalid operator. Right, and then I'm just going to actually output the operator, let's say op, and then let's say, right, was chosen. Right, and then yeah, this should work. So let's say 5, let's go again 3, and this time let's say multiply. Yeah, so we see multiplication works. Let's say, for example, 5, let's go 3 again, and let's try a, right, so like an invalid operator. And then, yeah, here so it says, what, invalid operator, a was chosen. So I think that's fine, right? Let's now try actually have like a range in this case. So let's maybe delete, yeah, let's delete all of this. Probably I'll just have 1 here, and right, let's also delete this. Right, I'm actually also going to delete the case because, I think it's good to practice from scratch, you know, rather than just sort of copying, pasting and modifying that. Because, yeah, I guess maybe you'll, you know, kind of, it doesn't really solidify in your memory, you know, if you're just copying and pasting. Right, anyway, so let's say here, grade. Maybe, yeah, let's say enter your grade. Or, yeah, maybe like mark. And let's say this can be right from 0 to 100. Right, this is then going to be mark. So again, if we remember, well, we just say case, right? Then we say of. So yeah, this of you have to remember. Right, then we just go mark. Then we go end case. Now, as we saw before, you know, we can have single values. Like we could say 0, then 1, then 2. But of course, you know, that's going to be extremely slow. Yeah, we'd have what, like 101 different cases, and then also the otherwise condition. So what we can actually do, we can just use 2. So if we say 0 to, let's say 40, maybe let's say output, yeah, unlucky, yeah, you failed. Right, then let's have a condition of like 41, and I'm only going to do a few of them. I don't know, let's say to 70. I mean, here, let's just go like C or something. I don't know, yeah, you got us. Let's say like not bad. You got a C. Now, of course, if this was a real program, you'd probably want to have like what, E, D, right, more grades. But yeah, this is just a simple one. Right, let's say 71 to, let's say, I don't know, yeah, to like 90. Well, I mean, let's just go to like 97 or something. And then, yeah, let's say good job. All right, good job, you got an A. And again, obviously, this is not realistic, right? There's no B grade, for example. But yeah, just for a quick kind of like demo example. Right, so then what we can do, I mean, here we've seen then the range, right? We can also have just the comma to separate values. So let's say if they get 98 or 99. And the thing with this, I mean, we could actually go 98 to 99 because it's just in a range. But like, these don't have to be consecutive, right? For example, we could go like, I don't know, 98 or -6, right? We can literally just use random values like this. They don't have to be consecutive. But let's say here, let's go, yeah, output, I don't know, let's say like almost perfect. And then let's say if they get 100, let's go output, and I know we'll just say, yeah, you're a genius, 100%. And then right here, if we just go otherwise, let's say, right, mark, and we'll just say what, yeah, is an invalid grade, or yeah, invalid mark. So again, right, these are just the 3 different things we can use in case, right? We can use 2, so if we've got a range, and I think this will work for both kind of increasing range, right, so ascending, right, and it will also work for a descending range as well, so like 40 to 0. Right, we can also use a comma to have multiple values. Then of course we can just have a single value like this, and then, well, otherwise, I mean, this is like the else condition basically. So right, unexpected token. Okay, it's because I forgot the output here. Right, so let's say we get, I don't know, let's say like 20. Yeah, unlucky, you failed. Let's try 98. Yeah, almost perfect. Right, let's try 100. Right, you're a genius. And let's try -5. Yeah, invalid. And let's also try 101. Yeah, that's also invalid. All right, so again, if you're testing this, well, just think back to, normal, abnormal, yeah, boundary, extreme. Right, so, make sure you're testing all of those conditions. But all right, so I think that's fine. Then if we move on to loops, and I'm just going to copy this again because, yeah, I think otherwise I'll have to keep, scrolling up and down. Right, and then I think I can delete those. Right, so the first one then, we just want to output the 5 times table. So the syntax for a for loop, well, we say for, right, then we have the count variable. Now this variable, we can call anything. I'm just going to call it n. I mean, some people call it index, some people call it count. Yeah, maybe I, right, yeah, x, right, basically anything. Right, and so here then we say the starting value. Now let's say in this case I'm just going to start at 1, and then, yeah, what we can do, let's go 2, okay, let's go, well, to 100, and then I'm just going to output, and let's go output, maybe, yeah, n times 5, right, just like this, and then here let's just go next n, so this should just output, 5, 10, 15, 20, yeah, and we see that. And again, up until, well, n is 100, and we can see here, right, 100 times 5. Now, there's actually another way we can do this. So here, by default, well, we have step. Now, the step is how much n will change each time. So, for example, if here we just output n, well, this will just output, 1, 2, 3, 4, yeah, up until 100. Okay, which we can see. Now let's say we change the step to 2. So the step is just how much it will jump each time, right, or how much it will increment. So yeah, here it's just increasing 2 each time. So if we want to do the 5 times tables, well, we could do something like this. All right, we'll start at 0, then let's go until 1000, and we'll just do a step of 5. Right, so this should go 0, 5, 10, 15, 20. And yeah, we see this, right, up until 1000. Right, so let's say the next one we want to do the 3 times table from 300 to minus 300. So here then we're going to start at 300. Then we're going to go to minus 300. But then this time we actually want minus 3. Alright, so yeah, we can actually have a negative step. And yeah, that goes, so 300 to minus 300. Right, we can also have a decimal. So let's, I don't know, maybe let's go from like 100 until 200, or yeah, okay, maybe 200. And let's say here we're going to have a step of 1.5. Oops, and then yeah, you see, right, this also works. And then here it gets to 199, because I guess the next time, well, then it's going to go 199, plus 1.5. Right, that's going to be 200.5. And yeah, I guess 200.5 is going to be bigger than this. So yeah, that's why it kind of stops at 199. Alright, and then we can also even have a variable n, or well, let's say a variable step. So let's go to declare. Let's call this I don't know, step value. Right, the step value can be an integer, and let's just start this at 1. Right, so here the step value. Right, let's maybe start at 0. Yeah, we'll go to like 1, or yeah, I don't know, maybe 10,000. And let's say here we want to output n, but then we also go the step value. I mean, we could just go like +1, right? So step value +1. And I guess here, right, so it goes, well, 2, 5, 9, because here what we've got a step value of 2. Right, then step value 3, 4, 5, 6, yeah, 7, right, etc. We could also do something like this, right? Step value plus n. Yeah, okay. I mean, let's try this one. And then here, what this goes to, then it goes 4, then it goes what, 13. Yeah, okay. So I guess it just does this pattern. Alright, so I mean, I think for for loops that's everything. Right, just try to remember the syntax. So we say the starting value, right? Then we say the ending value, and then while this step is optional, right? So again, if we don't have the step, then it will just do +1 by default. So let's just delete these. Yeah, so here again it just does +1 by default, right? If there's no step. Okay. Alright, so actually I think we also want this, right? We want a sum. Yeah, and it was a good job I wrote that substring, because otherwise I would have forgot. So let's say here we also want to sum the first 100 numbers. So let's call this sum, let's go integer. We will just assign it the value 0 here to start. Let's say we want to go from, well, I mean, yeah, 0 to 100. I mean, now honestly we could just start this at 1, because, well, 0 plus 0 is just going to be 0. But then what we can do, well, let's say sum, and this is going to be equal to sum plus 1. Okay, no, sorry, not plus 1, right, plus n. Now, if we think about this, right, because some people get confused when they see, sum equals sum plus something, because, we're kind of plussing it with itself. But again, right, so sum starts at 0, and, well, n starts at 1. So here we've got, well, 0 plus 1. Okay, so this is going to be 1. And this means that 1 is going to be assigned into this into this sum variable here. Right, now on the next iteration, well, the next iteration n is going to be 2. Right, so here, well, sum was 1, right, then we've got, well, n is 2. So 1 plus 2 is going to be 3, right, so 3 is then assigned back into sum. The next time, what, we've got 3, and then, well, n is also going to be 3, so yeah, 3 plus 3 is going to be 6. Yeah, obviously, etc. Right, then if we just output the sum, and then yeah, we get this, and I think this is correct, because you can also use the arithmetic sequence formula to actually calculate this as well. Yeah, if people do statistics, maybe they know that formula. Right, okay, yeah. Then we also want a substring to out the characters, or output the characters. So let's say maybe, I don't know, just name. Let's say this is a string, and again we will just assign this. Let's say, I don't know, let's say like Pseudocode Pro. Right, so here what we can do, well, we could actually count how many characters there are. right? But if you remember, we also have this length function. So this length, well, basically it will just count the number of characters here in a string. So I guess here this is, well, however many characters that is. Right, and then what we can do, you know, we can also assign this to a character variable if we want, but I'm just going to output directly. So we want substring, the string here is going to be name. Now this time the starting position is going to be n, right, because first we want the first character, then we want the second character, then the third character. Right, and then here we just want to get one character each time. And yeah, let me just delete that. And then yeah, okay, so here you see, obviously we just output all of the characters. And you know, we can also do something like this. Again, if we go step, let's say step 2, well, of course that's going to output P, then E, then D, right? It's just going to skip. Yeah, it's just going to skip like every other character. Right, so I mean, if we look then at for loop, well, that's a count controlled loop. I mean, basically that's good if we know how many times we want to loop. Like for example here, well, we know that we want to loop. I mean, yeah, like however many characters that is, all right? Because obviously we can just calculate this. But let's say, for example, we have a situation like here. We want the user to type in their username, and we want them to keep. Well, we want to keep asking for input. You know, like while they enter kind of an empty string. Now they could enter a valid username the first time, in which case, you know, we only need to loop one time. Right, or they could enter, you know, like an invalid character 5 times, in which case, you know, of course we need to loop 5 times or ask them 5 times. Yeah, so in like if we don't know how many times we want to loop, right, that's when we can either use a preconditional while, right, or a post-conditional repeat until. And the difference is that, well, a while, because we check the condition first, yeah, let's say if this condition is false, then it's never going to execute the code inside that while loop. Whereas repeat until is always going to execute the code inside the loop at least one time. So yeah, let's just see how we can do this. Right, I'm just going to change this. Maybe let's call it username. Right, let's just let's just kind of have that empty. Right, and then what we'll do, let's say while, and we'll say while username is okay, hang on. Right, let's say while username is equal to this. Right, and then I mean here we can have do. However, do is actually optional in the new syllabus. I mean, I'm going to include it just, you know, I mean, yeah, why not? Right, then again, we need to remember end while just to close it. Let's go output. Right, let's say, all right, yeah, please enter your username. Right, then let's go input. All right, and we'll just input username. Let's just say, yeah, maybe welcome. And then we will say username. All right, so what this is going to say, well, while username is equal to an empty string, right, then it's going to keep asking them. So here, right, let's say I don't type anything. Right, again, you see it's going to ask me again. You know, we can also see it here as well. Let's just say ABC. And then, yeah, here, finally, it's going to say welcome ABC. All right. And as we saw, you know, the reason we use a while loop is, well, you know, we don't know how many times to loop. Because maybe they enter the username correctly the first time, you know, or here it takes them like 5 times to enter it correctly. So let's just extend this. Let's also then go password. And we'll try, yeah, right, let's actually give it maybe 2. Maybe let's say like user, on a user input password or something. Let's say like real password. Right, so basically here there's going to be 2. There's going to be a real password, which is, you know, what they, well, yeah, what's actually correct. So let's say ABC123. And then, you know, the user is going, well, we're going to keep asking the user to enter their password until they enter, you know, this correct value. So here, let's go repeat. Right, again, I'm just going to go until, and I'm just going to write the condition first. So the condition is going to be, well, until user input password is equal to the real password, or, you know, the kind of correct password. Right, let's say maybe, Alright, okay, let's say like please, okay, hang on. Right, let's say username, like please enter your password. Right, and then here, let's just go input, and we will then say, yeah, that's going to be the user input password. And then I think this welcome message is fine. Right, so username, well, let's just say, yeah, ABC. Right, and then it says ABC, please enter your password. So let's say 123, right, yeah, that's incorrect. You know, something else, right, again, incorrect. Right, then if we type ABC 123, and then, yeah, finally we get this welcome message. Right, so I think again, I mean, probably I think that's enough of, you know, these examples here, because, well, otherwise the video is going to get, you know, super long. But I would say, you know, try and practice these, try and practice all of these loops, right? So again, for, while, and then, yeah, repeat until. And to be honest, you know, if you actually go up here, yeah, let's maybe minimize this. You know, I do have a lot of challenges here, right? Also, all of these starter questions for the exams. You can also click here. In fact, yeah, maybe let me just show you. Yeah, for example, you see here, right? We've got, you know, all of these starter questions for the IG. I mean, likewise, A level. Although I guess, yeah, if you're doing IG, you know, probably just focus on these. And for example, like, I don't know, let's click on this, daily temperatures. Yeah, I guess my internet is a little slow. Alright, so yeah, you can see it's finally loaded. Now, you know, basically this will load up, you know, with all of the actual kind of data that, well, Cambridge says, you know, that they give you, basically. Because in the exam questions, they'll say, you know, yeah, this variable has already been declared, or yeah, this array has already been initialized. So, you know, you can use this, and yeah, this just gives you a load of like random data that you know, that kind of you can use. And then you can just directly start typing your code here. Although, yeah, you will need to click on this opening code editor to actually, you know, execute it. But anyway, yeah, let's go back here. Right, and then let me just maximize it again. Alright, so yeah, now then, well, let's look at arrays, because I think this is something that a lot of people struggle with. Right, I'm just going to copy this. So let's say for this particular example, well, or in fact, yeah, actually, let me just copy all of it, to be honest. Right, yeah, let's copy all of that. Right, so for this particular example then, what we want to do, we just got this array of goals, and we want to find, well, the minimum, maximum, right, the mean, and then the total number of goals scored. And then I guess, yeah, I guess we can also output the player who scored, you know, the total number of goals. I'm sorry, the player that scored, you know, the maximum number of goals or something. Right, okay, so actually, I mean, in this case, this is actually already sorted. So I think I'm actually just going to change the order here. Maybe let's put Haaland at the end. Yeah, I guess I just use the data kind of directly. Alright, there we go. Alright, so let's say what we want to do. Let's declare, well, min. Right, let's also declare max. I guess we can declare the mean, although we don't really have to. In fact, actually, sorry, let's declare total. Right, because all of these, they're going to be integers. Now, if we think the mean is actually going to be a real, although, yeah, we don't really have to declare this, because, you know, we can just kind of output it and, you know, directly calculate it, you know, in one go. Right, so in order to actually declare an array, let's go declare. We'll then say goals, and then here we say array. Right, now here we actually say the dimensions. Now, I think this array, basically there's going to be 10. Right, because if we count these, yeah, basically there's, you know, 10 values, right, 10 elements. So that's what we say. We say, well, we start at index 1, right, then we end at index 10. And then here we just need to say of, right, and then we say the data type. Right, so the goals here is going to be, well, of type integer. And what we can do, you know, to actually assign this, we can then go goals. Then if we say index 1, well, index 1 is going to be 16. Because, yeah, that's going to be, you know, this value here. Right, then if we say goals 2, you know, that's then going to be 15. And of course, you know, we can do this for all 10 of them. However, yeah, that's going to be a little bit tedious. So Cambridge, they do say now that you should be able to just assign it like this. So here we're just saying goals, and then we're going to assign all of the values like this. And this will work as long as these values are of the correct data type, right? And also as long as it's kind of the same dimensions, right? So here we've got basically 10 values, and in fact, well, let me just run this. Yeah, okay, so no errors. Right, now if we just delete that, yes, it can't assign 9 values to array of size 10, and then it tells us what the index is, 1 to 10. Likewise, if we go another one, yeah, okay, it's going to say can't assign 11 values. Alright, so it should check the size. Okay, and then, well, basically we just want to loop through this. Yeah, let's loop through just to actually output them. Right, and I think what I'm going to do, I'm actually going to make a constant, because for A level we can actually use length to actually count the number of elements in an array. However, for IG they say that length only works for strings, right, not for arrays. So usually they would give you like maybe a variable or a constant that tells you, say number of students, or in this case like number of players. So let's go constant, maybe like num players. And then here let's say this is 10, right? So basically we're going to loop, well, 1 to 10. Let's say 1, and then okay, 2, and that's going to be 2 num players. Right, then let's remember to go next n, and we'll just output, and let's go goals, and this will be n. Right, so this should just output, yeah, all of the goals. Yeah, and we see this here. Right, so I think now then we can look at how we can actually calculate the min, max, total, right, mean. So sometimes I see people doing this where, for example, they'll go min and they'll just give it some value, like let's say they say min starts at 0. Now, in this case this would actually work, right, because, well, all of these are going to be bigger than the minimum. In fact, no, sorry, yeah, okay, this wouldn't work. So they might set min to some huge value, like for example they just go like this. Now here this would work because well, this 16 is going to be smaller than the minimum, right? Therefore this minimum would become 16 like on the first time. However, the problem with this is, well, let's imagine we were doing data for like I don't know, the size of the universe or something, or yeah, the size of different galaxies. Well, in this case, maybe even the smallest galaxy would be, bigger than like this many kilometers, or yeah, whatever that unit is. Likewise for max, right? If some people set the max as being 0, and then they say, well, let's say here, this would then be bigger than 0, so it sets it. But let's imagine we've got temperatures, and all of the temperatures are negative. Well, then the final result, it would think that this max is going to be 0, because yeah, 0 would be bigger than all of those negative values. So basically, like the best way we can do this is we just want to set this to be the first value. Now here we can just simply go like this, right? So we say, well, minimum is going to be goals and then 1. Now this is quite easy because we've already got the values. If you don't, maybe if you're asking for input or something, right, you could do something like this where you say if n equals 1, right, then basically you would then just copy this, or you would basically assign the input into this here. Yeah, maybe let's just skip that. Alright, so yeah, that should be fine. And then what we want to do, we then just want an if statement. So well, I guess the first one is a little bit redundant, to be honest. Right, we can actually start at 2 because we've already assigned the min and the max. So let's go if goals index n, and we want to check that if this is less than, right, if this is less than the minimum, right, then we're going to set the minimum to be this new goals. Right, then let's go end if. Right, so if we think about this, well, the minimum here is going to start at 16, right? Then on this loop, we're going to check goals index 2. So goals index 2 is going to be 15. So here we're saying, well, is 15 less than 16? Right, so in this case, this is true. So then, well, then we're just assigning this 15, and we're assigning 15 as being the new minimum. Right, then the next time it's going to go to 14. Well, 14 is going to be, the new minimum. Now, I mean, this one is, kind of quite easy, I guess, because it is kind of sorted already, other than this, like 18 at the end. But yeah, I mean, basically, we then just want to do the same for max. So we just go if goals n, and this time we say if this is bigger than the max. And then what we're going to do, we'll say the max is then equal to this goals n, or yeah, we'll kind of assign it. Right, so that should be fine. And then let's also do the total as well. So here the total can start as, well, goals 1. And we could also start this as 0, but if we start this as 0, right, we would then have to start the loop at 1, just so we don't forget to actually, kind of, yeah, add this first one. But yeah, I'm just going to start at 2 here. And then what we're going to do, let's say total. Again, we're just going to kind of increment itself, right, or yeah, add it to itself. And that's going to be total plus goals n. And then I think, yeah, then we can just output this. So let's go min. Right, and I mean, this should also be correct. Right, then let's go max. Right, that's going to be max. Let's go output. Right, this can be, yeah, total. Right, that's going to be total. And then if you think, well, we can also, yeah, just directly calculate the mean. Because if we think the mean is just going to be, okay, let's also round it as well. So let's say here this is going to be total, this is going to be divided by the number of players, and maybe let's round it to 1 decimal place. And yeah, let's check this. Yeah, okay, so we see the minimum is 11, right, which seems correct. The maximum 18, yeah, that's correct. Total, I mean, probably correct. And then yeah, the mean, well, we've got 10 players, right, therefore this, yeah, this seems correct. Right, now let's actually extend this where we want to say, for example, here it will be, yeah, for example, it will say Foden, right? So Foden scored 11 goals, right, which is the minimum. I guess, yeah, Haaland scored 18, right, which is the maximum. Now, I mean, in this case, there's actually 2 that have got 11, right, but let's just ignore that. Likewise, of course, there could be 2 that share the maximum, but yeah, we'll also just ignore that. Right, okay, so what we want to do then, let's also declare here, maybe like min player name. Let's also go max player name. Right, this is going to be a string. And let's also just copy these player names. And then if you think we're just going to make another array, let's call it players. Again, this will also be size 1 to 10. But then this time it's going to be of type string. Right, let's go players, and yeah, we'll just assign this. Right, what we want to do then, we want to say the min player name, that's going to be players, and then index 1. Right, max player name, again, that's going to be players and index 1. And then basically when we set the new minimum, well, we also want to set the, the min player name. Right, and then that's going to be equal to players index n. Right, I'm just going to copy this. And then this one here is just going to be max player name. Yeah, I don't know, I mean, let's just go like, maybe have a space, and then we'll just go the min player name. Yeah, I mean, this is not the best formatting in terms of like, making a nice sentence, but let's just check if it works. Yeah, so we see 11 is going to be Palmer, or 18 is going to be Haaland. And the reason this is Palmer is because, well, this is a less than, right? Because if we think, well, Palmer got 11, and then we say, well, the next one, right? So this goals n, right? That's going to be the next one. So we say if 11 is less than 11, right? Well, that's going to be false. However, if we make this less than or equal to, or yeah, I guess also greater than or equal to, now it's actually going to say Foden, because, well, first it's going to set it to Palmer, but then we say, well, 11 is less than or equal to 11, right? That's going to be true. Yeah, then if we run it again, you see right now it just changes to Foden. But I mean, honestly, in an exam, they wouldn't give you questions like this where, you know, two of them have the same value, right? I mean, they would tell you, you know, all of them are going to be different values. Alright, so I think, yeah, that's fine. I mean, now if we look at 2D arrays, right, so I'm just going to delete all of this. And again, let's just paste this here. Right, I mean, so yeah, let me just close this, and I'll try and just kind of open this in, well, Excel or yeah, WPS, just to actually kind of demonstrate, you know, kind of how this looks. Because I know some people, they get confused with like a 2D array. And can I zoom in a bit? So for example, let's say here, I don't know, maybe we've got like first, I don't know, let's say like name and email. Okay, in fact, well, let's just do a 1D array first. So let's say we've got a 1D array called name. Well, let's say then you've got person A, person B, person C, person D, right? So in a 1D array, well, it's just one dimensional, okay? Basically, it's just a list. So yeah, like a 1D array is just a simple list. However, if we have a 2D array, well, here we're going to have both rows, right? And then, you know, we also have columns here like this. So let's say, I don't know, name A and email, I don't know, A, B, you know, just something simple. Right, okay, so here you can see, well, let's say if we want this one, right, this here is going to be row 1, column 1, right? Whereas if we look at this, well, this is going to be row 1, column 2. Likewise here, this will be, you know, row 2, column 1, you know, what, row 2, column 2, yeah, row 3, column 1, and then row 3, column 2. So, you know, a 2D array basically is just a table. And the thing you have to remember, right, it basically always goes row then column. And I think I've said many times before, I mean, the way we were taught at school, you know, well, we were taught like Roman Catholic. Because if you think, well, RC, right, so Roman, and then, well, C for Catholic, you know, row column. I mean, you can also remember something like remote control. You know, obviously, yeah, RC for remote control. Because, yeah, you do need to remember that it's row column, right? If you're using column then row, well, then you're going to get, you know, the wrong result. And, yeah, in many cases, you'll also get kind of out of bounds exceptions. Because let's say here, if you try to access, like, column 3, well, column 3 doesn't exist, right? Whereas, you know, row 3 does exist. So yeah, you'd also get, you know, out of bounds exceptions as well if you're using, you know, the wrong one. All right, so anyway, here then, well, the question, we got 2D array of capital cities. So I guess here we got the country. Yeah, then on the, you know, the second column we got the city. Right, we want to find the country, well, find the countries with the same name as the capital. So, you know, we can also just ignore this city part, right? So like Mexico and Mexico City, well, that's going to be the same name. I guess here, yeah, Luxembourg and Luxembourg. All right, that's also going to be the same name. So again, let's just declare this. Let's maybe call it, I don't know, cities. Yeah, I think that's fine. And then this is going to be an array. Now, here we've got to think, all right, we've got 5 rows. So the rows here is going to be 1 to 5, right? Then we just say a comma for the, you know, kind of second dimension. Now the second dimension here is going to be columns, right? And while here there's only 2 columns, so we just say 1 to 2. And then both of these, they're going to be string. Now the thing with pseudocode is that basically everything in the array has to be the same data type. So you couldn't have it where you have, say, a string in column 1, but then like an integer in column 2. Right, you know, they would both have to be strings. And that's why for this one, yeah, like here we had this 1D array of integers, right? Then we had, you know, the one-dimensional array of strings, right? But we had, you know, 2 different arrays. Yeah, rather than actually rather than like storing them in the same array, basically. Right, okay, so yeah, again, let's just copy these. So again, let's go cities, and in fact, I mean, well, let's look at how we can assign these. So let's say here 1, 1, right? Well, 1, 1 is then going to be Mexico, because again, this means like row 1, column 1, Then if we go cities and then write 1, 2, well, this means row 1, column 2. Well, that's then going to be Mexico City. Of course, you know, we can then continue this, right? If we go, let's say 2, 1, well, 2, 1 is then, you know, Egypt, right, like this. Yeah, however, again, I'm just going to try and do it a little bit faster. Yeah, this is a little bit annoying. Alright, let me just uncomment those. Yeah, I realise I probably should have done this before. Alright, and then let's try and make it look a little bit nicer. Okay, so I think that's fine, and you know, here we can see it quite nicely, right? Because, well, you know, row 1 is going to be this, row 2 is going to be this, and then obviously, yeah, like row 1, column 2, well, that's going to be this one. So first, let's just try and output, you know, like Mexico City is the capital of Mexico. So in order to do that, well, let's go for, again, let's also make a constant. Let's call it like num cities. And here we're just going to say 5. And, you know, we could also change this to num cities. Right, that's also going to be fine. Let's say n. Right, and then let's say here, this will start at 1. And then we'll just go 2. And yeah, this will be 2, well, 2 the number of cities. And then what we're going to do, we're going to say cities, the row is then going to be n, right, and then the column is going to be 2, because we want to say like Mexico City is the capital of Mexico. Right, is the capital of, and then yeah, let's go cities, and that will be n, and then 1. Right, and then we'll just go next n. Alright, so I think this should work. And yeah, okay. So we see this is working quite nicely. But then what we want to do, well, we only want to output Mexico and yeah, also Luxembourg, right? So we need to think, how can we actually determine, you know, if the city, yeah, like how can we determine, you know, if the sort of city and capital are the same, or sorry, yeah, if the city and country name are the same. And you know, again, we can just ignore the city part, right? So this one we can actually use kind of a little trick with strings, where basically we can get the length of the country name, and then we want to check like if the capital starts with the you know, same string as the country name. All right. Yeah, I mean, let's just output this first, you know, just to actually kind of test, see what this does. So what we want to do, we want to say substring. Now here we want to start from character 1. In fact, sorry, so first we actually need the string, right, so that's going to be n2. Right, so again, that's going to be column 2. Then we want to start from character 1. Okay, and then the number of characters we want to get is going to be the length of this. So here then we're going to go length, and that's going to be cities, and this here will be n1. Alright, so this should just output, you know, Mexico, and then actually here this is going to output, well, this will output Cairo, because it's the same. But for example, like here, I mean, I don't know, let's say this is the country, then yeah, this would actually only output these first 3 letters, right, C-A-I. I guess it's just coincidence that, yeah, this has, well, 5 and 5, right? These have 4 and 4. I guess this one will probably be shorter. Yeah, so we see this is cut off. All right. And then I think what we want to do, well, we just want an if statement. So we can just say if. And then what we will say, well, we want to check that if this is equal to, yeah, this city's 1. Right, so here we're saying, well, kind of if the first part of this cities is equal to, you know, cities 1, right, then this means they have the same name. Yeah, let's say like has the same name as the country. Yeah, has the country. Alright, and then yeah, hope this works. Okay, right, so yeah, I forgot the then. And let's also just move this across. And it seems, yeah, I've also forgot the end if. And yeah, we see this works, right? So Mexico City has the same name as the country, and also Luxembourg. So I think that's fine. I mean, sometimes it's actually a little bit more complex than this. Let's try, for example, like numbers. And yeah, maybe let's call this like num rows, right? And then, yeah, let's actually just delete all of this. So what we'll do is we'll try and make a grid. Or yeah, maybe let's call it grid, I guess. And then what we can do, yeah, let's say this can be num rows. This can then be num columns. Alright, let's say num columns. And I think, yeah, I can't do that for a constant, actually. Right, let's say it's going to be 3 rows, constant num columns. Maybe there can be 4 columns. And then, right, so here then we're going to say num rows. Here we're then going to say num columns. Right, and then let's just make this an integer. Right, because what I want to do is I want to practice just having like 2 loops, right, so a nested loop. Right, let's say this is going to be grid. Now what we're going to do, let's say this can just be 1, 2, 3, 4. Or in fact, yeah, let's go 5, 6, 7, 8. And then we'll just go, what, 9, 10, 11, and 12. Alright, so I think that's correct. Yeah, we've got 3 rows and then 4 columns in each. Now, if we want to output all of these numbers, right, then here we're actually going to need 2 loops. So first we're going to loop through the rows. Alright, so we're looping through row 1, then row 2, then row 3. This will start at 1, and then we will go to the number of rows. Right here, then let's go 4. Let's say num, right, this can be column. That's going to be 1, and then we will go to the number of columns. And then in here we can just output directly, so if we just get output row then column, let's go next column, and let's then go next row. Right, and then this should just output them all on a different line. Yeah, okay. Now, sometimes we might want to actually kind of, let's say we want to output all of these on the same line. Right, so what we can do, for example, let's go declare, and let's say line, and this can be of type string. Because the thing is, right, output always outputs on a new line. So what we want is, well, we want the line to be, you know, set to an empty string, kind of for each new row. So if here we go line, we'll set that to an empty string. And then what we'll do is, rather than outputting, well, we'll just go line, and then that's going to be line, and then kind of and. Now, technically, I mean, I don't think they include this and in the syllabus, alright, so they probably shouldn't want you to do this. But yeah, this will just join 2 strings together. Right, and then, well, what we can do is then if we just go output line, and let's also just have a comma as well. Or yeah, maybe just a comma and a space, probably. Alright, I mean, this won't be perfect because it will actually have, you know, an extra comma at the end. But yeah, let's see if this works. Alright, and then yeah, so here we can output them all on the same line. Because, well, again, we're just, you know, concatenating them, which means like just joining the strings. Yeah, we're kind of joining the strings together. And, you know, if we think again, this is similar to total. Right, where, well, line, it starts as an empty string, right, then we're, you know, well, concatenating or joining with the current number. So this is like empty string and 1, right, so that's just going to be, you know, the string 1. Yeah, then we also join it with, you know, this kind of comma space. Right, and, you know, then on the next loop, well, then line is going to be, you know, 1 comma space, and then, yeah, and 2, right, and then we're also going to, you know, concatenate the comma space as well. So yeah, it's just going to join them all together, right, concatenate them together, then it just outputs at the end. Now, you know, if we actually don't want to have this comma space at the end, what we can actually do is, well, let's say if, and let's say if column is less than, yeah, I think less than number of columns, then we can do this. Right, then we'll have else, then let's go end if, and I guess else we can just output this, oh yeah, we just concatenate the first part. Right, so yeah, if it's, well, if it's less than the number of columns, right, then we're going to add this, whereas I guess, yeah, if it's equal to, so for example, if it's column 4, right, then we're just not going to have the, you know, yeah, comma and space. All right, and then yeah, we see that works here. All right, so I think yeah, that's all we need to do really for arrays. I mean, later we'll go back and we'll look at linear search, also bubbleSort. But yeah, I mean, let's first just look at how to actually make these functions, or yeah, how to make our own custom functions. Okay, so right, let's just delete all of that. Right now, the first one, Pythagoras. I mean, this one's quite simple. We just want to give, well, we want to give a and b as parameters. Okay, then return the value c. So if we just go function, let's say Pythagoras. Right, we're going to say a and b. Okay, these are both going to be integers. And note again, okay, because a and b are the same type, right, I can actually use the comma like this. Now I could also just do it like this, where I go, well, a integer, and then b is of type integer, right, that's also fine. But yeah, you know, again, right, if they're the same type, right, we can just use this. And to be honest, I'm actually going to make this a real, because I guess we can probably, you know, have a real number for the, you know, dimensions. Right, then for a function, we're just going to say returns. And well, here it's definitely going to return a real, because even if these two are integers, right, then it can also still return a real. Right, and then again, I'm just going to get end function so I don't forget. And then what we can do, we can just go return. Now, if we think about this, well, here, you know, basically just what a times a plus b times b. But if you remember, we can use a squared like this, and then let's go plus b squared. Now, you could have brackets if you want, so you could go, for example, a squared in brackets, and then yeah, b squared in brackets. However, in this case, you actually don't need it, because, well, this one takes higher precedence. So yeah, like exponentiation has higher precedence than addition. So, you know, it's going to do these first, basically. And all right, in pseudocode, there actually isn't a square root. However, if you know the laws of indices, well, then a square root we can do just by, you know, raising to the power of 0.5 like this. And then, yeah, if we just output this just to test it. So I think one of the Pythagorean triplets, right, 3, 4, 5. So yeah, this should output 5. Yeah, okay. And then, you know, if we try, I don't know, like, well, let's try 35 and like, yeah, I don't know, 404. And yeah, I guess we get this, right, which is the answer. Right, so that's fine. And then if we look at the next one, right, isPrime. Now, we want to think how we can check if a number is prime. So basically, one of the ways we can do this is, well, we just loop through all of the numbers. Like, let's say we're checking 10. Right now, we don't have to check 1. Or in fact, well, let's say we're checking 11, because I guess 10 is a prime number. So we don't have to check 1 because, well, you know, anything divided by 1 is always going to be a whole number. But, you know, we can do mod 2, right? So we want to, in fact, let's use mod like this. So we go 11 mod 2, and then we just check, well, is that equal to 0? And then if it is equals to 0, well, then this means that 2 would be a factor of 11, right? Because, like, for example, let's say 10. Well, 10 mod 2 would be equal to 0, right? So this means that 2 would be a factor of 10, which means that, of course, it's not going to be a prime number. But, for example, let's say 11. Well, this is going to be false, right? This is not going to be equal to 0. Then, of course, we go 3, right? Also not equal to 0, 4, right? Not equal, and, you know, we just keep going. And I think I mean, a simple way is you think, well, we only have to loop until kind of like half of this. Because, for example, like, I mean, let's say, for example, I don't know, maybe let's try like 20. Well, the thing is, you know, we do 20 divided by 2. Well, that's going to be 10. But then, you know, 20 divided by 10 is going to be 2. So, like, 10 and 2 are basically pairs. So, yeah, we only need to check kind of one of them. So, yeah, that's why we only need to loop up until half. Now, I think you can actually optimize this even further, where you actually only have to loop up until the square root of this. And I mean, yeah, you can check that, but, you know, I think that does work. Right, so again, I'm just going to delete it just so we can practice actually, you know, writing the whole thing again. Alright, so if we go here, function, let's call it isPrime, and I mean, let's call it, I don't know, maybe num to check or something. We could just call it n or something. Right, and then here, well, we're just going to return a boolean. Alright, because it's going to be true or false. And then what we want to do, well, we just want to loop. So let's say for, let's say n is going to be 2. And then, right, I'm just going to declare this, let's say maybe max. Right, that can be integer. And then I think this is correct where we can actually go round. And then let's go num to check. Right, and then, yeah, I'm just going to go to the power of 2 like this. And then, yeah, we'll just round it to 0 decimal places, right, so just a whole number. You know, now you could do this, right, I mean, you could also just go to, like, you know, num to check -1, right, that's also going to be fine. However, this is just going to be a little bit more efficient, right, so obviously it's going to check less numbers. Right, let's go max, and let's just also output, maybe let's go checking, and let's just say n, right, just to actually see what this is checking. And then, you know, I'll delete this at some point, but just for testing. Right, let's say this, we want to say if mod, this is going to be num to check, and we're going to do that modulus with n, right, if that is equal to 0, well, then we're going to return false, right, because again, this means it's not a prime number, right, then we just end if, then we just go next n, right, and then, well, the condition where it is a prime, this is where we've looped through, you know, we've checked all of the numbers, and then, yeah, if it's never returned false, well, that means it then must be a prime number, right, because again, we've tried to divide it by every number, right, none of them is like a valid factor, yeah, therefore it must be a prime number like this. Alright, let's go isPrime, I mean, let's try, for example, 10, right, so 10, I mean, it should say false, I guess it's just going to check 2, yeah, so checking 2 then says false, right, let's try 11, yeah, okay, and I mean, so here it's only checking 3, and I mean, I think this is correct, you know, obviously it's because we do this round, maybe I'm just going to actually do num to check. Let's try num to check, and in fact we can do div of this. Right, let's just divide that by 2. Yeah, then it's also checking 4 and 5. Now, to be honest, you know, I think that square root thing does work, but I mean, yeah, let's just do this just to be sure. Right, so actually I just checked because I wasn't sure, but I guess they say that 1 isn't a prime number, but 2 is a prime number. So in order just to have a simple check for that, let's just check this directly. So we say if num to check equals 1, right, then we're just going to return false. Yeah, because yeah, 1 is not a prime number. And then if we just test this, so 1, it should say false, yeah, and then if we check 2, yeah, so 2 says true, right, which is, I think, fine. Right, now again, if we want to output all the numbers from 1 to 100, well, let's have a for loop. Let's go 1, or in fact, let's go to, maybe let's go to 10,000, right, we'll have a bit more. Right, then let's go next n, and then we'll just say if isPrime, that's going to be n, and then equals true. Then let's just output n like this. Let's go end if. Alright, and let's also just delete this output checking here. And this should work. Yeah, it might take a little bit of time. Alright, so here it says it took longer than the 5 seconds. Now, if, you know, I could extend this max execution time if I wanted. I guess, yeah, 10,000 is a little bit too much. And again, you know, this is not the most efficient way because, well, we're checking every number individually. For example, that I think if you actually look on the search page, right, there is actually a more efficient way of doing this. I think even here, actually. Yeah, prime numbers. Basically, there's a method called the, well, sieve of Eratosthenes, and let's say 10,000. And there you see like 10,000, and that's done it almost instantly. And yeah, we've also counted here. Right, and now, I mean, if you're curious to see how this works, I mean, again, just click on this prime number program, and yeah, there's kind of a description of, you know, how it works and everything. All right. Yeah, so I think for primes, I mean, that's fine. Right, let's say the next one, right, we want to get the full name. So let's say here function, let's say getFullName. And what this is going to take is going to take a first name and a last name as parameters, right? Then it's just going to, concatenate them together, right? Then just return it. So let's say first, I don't know, first name, let's say last name, and let's say string, right? And then here, well, it's also just going to return a string. Right, and then, I mean, notice here, when we say what the function returns, well, we actually have returns with an S. So we say, yeah, this function returns the data type string. Whereas when we actually say the actual, when we're actually saying what to return, right, we just use return, with no S. And then here we're just going to go first name, and then, well, let's go and last name. And I think what I'm going to do, maybe I'm also just going to have a comma like this, just to separate them. Yeah, just to, format it nicely. So, I mean, let's just use the football example. Yeah, I mean, maybe let's not use Haaland. We'll use Fernandez. Yeah, okay, I think that's how you spell it. And then, yeah, here we see what output, right, Bruno Fernandez. And obviously, the good thing with a function is, well, we can just copy this over and over. And let's say here we want what, like Erling Haaland, and then let's say maybe, I don't know, yeah, Lionel Messi. Of course, we can use the same code, yeah, just call it over and over. And let's say, for example, like maybe we want to change this, right? So we want to change it to be last name, then first name. Okay. Right, and then, obviously the advantage is, well, we only have to change it in one place. And then, yeah, of course, it's going to change for all of these. All right. So if they ask you what's the advantage of a function, well, one, you can say it helps keep code organized, because we don't need to, copy and paste the same code hundreds and hundreds of times. Also, it's going to make it easy to make changes, because, you only have to change it in one place. And yeah, I guess that's the main thing, right? Just keeps it organized, yeah, easy to update, easy to change. If there's a bug, right, if something's not working, again, you only have to fix it in one place as well. Alright, so I guess now then, if we look at linear search, and probably I'll just, pause the video and try to demonstrate this. Alright, so I think some people probably know how to do linear search already, but for the people that don't, or the people that want a recap, let's imagine we just got this array here. Now, let's say we want to search for the element number 8. Okay, what we're going to do, and yeah, I'm trying to use this graphics tablet, I'm not very good. We're just going to start on the first element, and we're going to check, well, is this equal to 8? Right, no. So because it's not, then we go to the next element. Then again, we check, is 3 equal to 8? Alright, also no. So we go to the next one, alright, 7, alright, no, 2, no. But then when we get to here, of course, here we check, well, is 8 equal to 8? In this case, yes. Right, so here we can then just return true. Now, let's say if we were searching for 9, well, of course, we're going to go through the same process, right? We're going to start, well, is 4 equal to 9? Right, no. 3, no. Right, no, 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 no. Right, then we get to the end. And because we get to the end and it's not there, right, well, then, of course, we know it's not in the array, okay? And then here we can return false. So yeah, let's just look at how we can actually code this. Let me just make this full screen again. And yeah, I'm going to unplug the graphics tablet. Okay, so let's actually just make a simple array. Let's call it numbers. Right, and then yeah, let's remember how we can declare an array. Let's say maybe 6 elements. And yeah, let's just say this is an integer. Right, so if you remember, well, we can assign array elements like this, right, like 1, 2, 3, 4. Or we can just directly assign them in one go. So let's say, yeah, okay, I think that's 6. Alright, so then what we want, let's make a function, right, let's call it linearSearch. Now, I mean, we could actually pass an array as a parameter, which honestly, like if you were doing, a real, like, yeah, kind of like real programming, that's what you would do. However, for Cambridge, I mean, I think for IG, they'd say, well, just use the global one. So yeah, here we actually won't. Okay, we'll just always use, you know, this same global variable. And then let's also have maybe the number we're trying to find. All right, so yeah, the number we're trying to find, this will be a parameter. Right, and then here, well, it's just going to return a boolean, right? True if it finds it, false if it doesn't find it. Right, then let's go end function. So what we're going to do, well, we're just going to loop, and if you remember, well, let's go 1 and then 2. Now, I mean, here we could say 6. All right, now if it's A level, again, we can use like length to get the length of the array. IG, they're not gonna, they're not gonna let you do that. So I don't know, maybe like, yeah, number of nums or something. And again, you know, in any exam question, they would tell you, like, if there's an array of students, right, they would tell you there's 50 students in the class. I think others have been about temperature, and I think they tell you there's like maybe 24 readings per day, and then, you know, 7 days per week. So yeah, obviously in that case, well, you just loop through, you know, until 24, like 1 to 24 for the hours, and then obviously, yeah, 1 to 7 for the days. So anyway, right here, let's say the number of nums, and then what we're going to do, we're just going to check if they're equal. So we check that if the nums at index n, so, you know, currently at position 1, right, if that is equal to the thing that we're trying to find, well, then we just return true, because obviously this means it exists. Right, okay, and then, yeah, obviously, and then what if it doesn't find it, then it's then going to check, you know, the second time, right? So if element 2 is equal to the element we're trying to find, right, then element 3. And if it's got to the end of the for loop and it's not found it, well, then we can just return false, right, because this means it doesn't exist. So let's just try and output this. Let's go linear search, and let's try, or let's say we're trying to find 5. And then let's also output linear search, and we'll try and find like 9. Right, so this one should say true, the next one should say false. Yeah, and we see this is working quite nicely. Now there are kind of slight variations they sometimes ask you. One might be to find the position. So let's say if these are sorted, I don't know, this can be, you know, like say like marks or, yeah, number of goals, and you want to find which position a certain person is. All right, so like let's say if we have this with the goals, then, you know, if this is sorted, like we want to find, well, if someone scores 15 goals, right, which position are they in? So in this case, they would be, you know, the third highest scorer. But yeah, of course, that could be grades, you know, it could be, yeah, like anything, right? So here then, well, rather than returning a boolean, and maybe let's call this like get position or get index. Right, then this is actually going to return an integer. And then what we're going to do, well, if we find it, we just return n, okay, we return the position, and let's say if we don't find it, we can return -1, right, which just means it doesn't exist. Yeah, let's make that get index. So if we see here, well, get index, this should return 6, right, and let's just have one more, let's go get index, and we'll get 8, right, so this should return 1. And yeah, so we see this works. Right, now let's also have maybe count. I think we call it count occurrences. And yeah, I'm not really sure how to spell occurrences, but I think that'll do. Right, so then we can do let's declare. Maybe we call this count. Right, that can be integer. So here, the count will start at 0, and then if we find it, well, then we'll just go count and then just increment this. So yeah, here we're just counting, you know, how many 5s there are or how many 8s there are, for example. And then here, well, let's just go return count at the end. Right, let's call this count occurrences, and then again count occurrences. And I mean, again, you know, these are all just variations of linear search, where rather than returning true or false, you know, we're returning how many, right, or we're returning the index position. Right, I mean, so let's say here 5. Well, let's also make this a 5. So it should say there's 2 5s, and then there should be 0 9s. Yeah, okay, which we get. Right, so I think that's fine. Right, then if we look at procedures, yeah, hopefully not too much more. Right, so we want to draw a triangle. Yeah, okay, let's look at how we can do this. Alright, although to be honest, again, the concatenation operator is not actually included, so they probably wouldn't ask you to do this. But I mean, well, let's just see how to do it anyway. Right, so basically we want a triangle like this, where kind of each line is going to have, one more star than the other, so it's just going to be a right angle triangle. So I guess here this would be a triangle of kind of 4, right, because we've got, 4 lines, and then also, yeah, a kind of width here of 4, right, or a base of 4. So let's go procedure. Right, let's call it drawTriangle. Right, this is going to take, let's call it width. Right, that's going to be integer. Then we just get end procedure. Right, now the difference then between a function and procedure, as we saw, well, a function we're going to say returns, okay, because a function will actually like give an answer, right? It's going to return an answer, which we can use to assign to a variable. However, a procedure, well, again, this is also going to be a module. Okay, it's also like a group of code, yeah, a group of code that we can call throughout the program. However, it's not going to return an answer that we can assign to a variable. So I mean, it could do something like it could output to the screen. It could ask for input. It could do something with files like reading files, writing files. But yeah, it's not gonna return an answer that we can assign to a variable. Right. So if we go here, let's say, and I mean this one's a little bit more difficult, but let's go declare. We'll go line. Right. This is going to be string. Now, if you think the first time we just want one star. Yeah, so I'm just trying to think how we can do this. Right, I mean, I think maybe if we just go n, let's say 1, and then this will go to the width. Let's say line here is just going to be, I think line and then and star. And probably let's also just kind of declare this line, or well, just assign it the empty string. Right, then I think if we just go output line, then if we go next n, and yeah, I think maybe this might work. Or yeah, maybe this is going to be completely wrong. Let's try 5. Yeah, okay, so we see that works. Alright, and the way this is working, well, again, line starts as being an empty string. Then we just have 1 star, right? Then we output this. So that's going to be the first line. The next time, well, remember line here is going to be like 1 star because we did that the first time, and then we just concatenate with another star, right? So yeah, now line is going to be 2 stars, and then of course we output. Then obviously the next one, well, we got 2 stars, and then add another star is 3 stars, and yeah, obviously so on. So I think that's fine. And then right, let's look at the next one, split email. This was one I saw people asking about in the group yesterday. And when I say the group, I mean the IGCSE Discord group. Now, if people have not joined that, I would say, yeah, probably, you can join that because, well, yeah, there's lots of people asking questions there. And, you can usually get an answer pretty quickly. Alright, so yeah, that's probably a good place to join. But of course, also, ask any questions here in the comments. That's also fine too. Right, so again, let's go procedure. Yeah, I'm just going to delete this. Right, let's say split email. So what this will do, this will take an email, let's say, well, in fact, let's just call it now anyway. So what we're going to take, for example, abc@gmail.com. So what we want to do, well, we want to split this, and we want to get the username, which is going to be, this part, right? And then, well, we want the domain name, which is this part. So yeah, we just want to kind of output them separately. And of course, we could assign them to variables if we want, or we could do some other check, like we could find, which people are using Gmail or which people are using, Outlook or, like Proton Mail or, whatever. Right, okay, so here then, this can take a parameter, let's call it string. Well, let's call it email, it's going to be of type string. Again, I'm just going to get end procedure just so I don't forget. And then what we want to do, well, we want to keep looping until we find this. And I mean, for this, we can probably use a repeat until, right, or we can use a while. because we don't really want to use a for loop. And the reason for that is, well, like here, it's the 4th character, but like if we have a longer email, here it's going to be what, like the 20th character or something. So a for loop, we don't know what position it is, so we don't know how many times to loop. So let's maybe declare, and we'll declare like current character, right? That's going to be a char. And yeah, let's also declare an index. Right, that's going to be an integer. Let's say here index can start at 1. And I think I'll do it using a while loop, and then I'll also do it using a repeat until. So let's say while current char is not equal to the @ symbol. Right, however, we also want another condition, because let's say it's an invalid email. Well, then if we're incrementing this index, right, this will just keep going, and then it'll just, basically it'll go past, the length of the string. So yeah, I think we want and let's go, alright, and index is, yeah, I think less than or equal to the length of email. Right, and then this will just ensure you don't get like a kind of string out of bounds like error. Right, let's go end while, and then what we'll do, we'll say current char, and let's just assign that the value. And here, if you remember, we can use substring. We're going to use email. We're then going to say the starting position is index, and we just want to get 1 character. And here, let's just go index, and that'll be index plus 1. All right, and let's just test if this works. Right, so output index. This should output 4, right? Because it's going to be character 4. 5. Okay. So I guess it's because we have this one here. We could do like an index -1 here at the end, although yeah, that's not really ideal. How about if we put this first? Right, and let's set this to 0, and then I think, yeah, okay, all right, so this works now. Because if we think, well, we set it to 0, right, then we increment, and yeah, then we're getting this character, from index 1. Whereas before, what we were doing, well, if I just kind of undo, before what we were doing is, well, we were getting index 1, right, or character at position 1, right, then we were incrementing, so then it was going to position 2, which means, well, this here would be checking like character 1, but the actual value of index would be 2, which is, yeah, that's kind of why this would be too high, right? And obviously when this was correct, well, this would be like the character 4, right, that would be this, but yeah, the index would be 5 already. So can I do, yeah, control Y? And yeah, okay, that's 4. Right, so let's try and also do this just using a repeat until. So I'm going to copy this. Right, let's go repeat. And right, let's say until. So here we've just got to change some of the logic, because, well, while means do this while it's true. Right, whereas repeat until, well, this means do this while it's false. Right, so the logic is kind of opposite. So we want to repeat until the current character equals the @ symbol. Right, then, I think this one's a bit confusing. So we want to say current character equals the @ symbol, right, or, because yeah, this will be the stopping condition, right, or the index is greater than or equal to the length, right, so yeah, these would be the 2 stopping conditions. And if we run this again, yeah, so basically we still get 4, right, which is fine. So right, then what we want to do, then we want to get the left part, and then we also want to get the right part. Now the left part is going to be quite easy. Okay, we can just use substring. And well, we can use substring for the right part, but it's also a bit more complex. So what we can do, let's go output. Let's call it maybe user. This is going to be substring, right? It's going to be email. The starting character is just going to be 1, because we want to start from the left. Right, and then what we want to get, I guess, what, index -1. That should work. Yeah, so here we get user ABC, Right, now if we try the next one, let's say domain, I guess. Well, here this is also going to be email, but let's think the starting position. Well, if here this is 4, right, so we want to go index plus 1, okay, to get this. Right, index plus 1. And then we want to think how many characters we want. So I'm just going to make this a little bit more simple. Let's say A, and then like at B. Or yeah, maybe let's say, I don't know, AB at CD or something. So if we think here, well, the length of this string is 5, right? But then we only want to get 2 characters. So what we can do is, well, basically we do the length of the string minus the index position, and then that will tell us, that will tell us how many characters remain here. Right, so I think if we do this, let's go length of email and then minus index. Let's move that across. Because again, if we think in this example, well, the length of email is going to be 5. And then if we minus the index, well, the index is going to be 3. So yeah, that means here we're starting from index plus 1, which is 4. And then we're just getting 2 characters, which will be CD. All right, and I think that should work. I mean, let's just run it with this. Yeah, okay, that works. And then we can also try with our original example. Let's say gmail.com, and yeah, okay, that should also work. So I think with these substring questions, if the example is a bit complex like this, then again, just simplify the example. And I mean, obviously, literally just count like character by character. Yeah, just to make sure that the equation actually works. And yeah, that should be fine. Right, so now then if we look at bubbleSort, I mean, this is definitely going to be the most complex thing. So I'm just going to stop this now. Yeah, I'll try to explain it quickly. Right, okay, so if we just look at the same array we had earlier with linearSearch, basically we just want to sort this array in ascending order, okay, so from smallest to biggest. Now the way we do this with bubbleSort is, well, we're just going to loop through, kind of pair by pair, right, element by element, and then just compare them. So if we look at the first one, well, 4 and 3, we check is 4, let's say is 4 bigger than 3, right, because we want ascending order. Well, because it is, that means we then swap them. All right, so what we can do, we can write 3 here in this position, then we can write 4 here in this position. Now we look at the next one, so 4 and 7. Well, is 4 bigger than 7? All right, no, so 4 stays the same. Right now, 7 and 2, well, 7 is bigger than 7. 7 is bigger than 2, so yeah, we swap them. And then if we look here, well, now we've got 7 and 8, so no, 7 is smaller than 8, so it stays there. Right now, 8 and 1, well, right, 8 is going to be bigger than 1, right, therefore we swap them like this. I guess, yeah, I'll just write in the array brackets, although, yeah, we don't really have to. Now, the thing to note with bubbleSort, okay, and this is going to be one of the optimizations, let's change the screen. On the first pass, right, this, the rightmost position is now going to be the biggest element. And of course, if we were sorting in descending, so, biggest to smallest, well, this would then be, the smallest element. But yeah, because, I mean, basically it's going to be sorted, right, whether it's ascending or descending. So that means the next time we don't actually have to check this element, right? So each time we can kind of check one position less. And the other thing to note, okay, is that, well, here we have 6 elements, but if you look at the number of comparisons we had to do, well, we compare these, right? So that's comparison 1, right? Comparison 2, comparison 3, comparison 4, and comparison 5. So we've got 6 elements, yet we're only doing 5 comparisons. And the reason for that is because, well, when we get to this, this element here, we can't compare it with, this element, because of course, well, this element doesn't exist. And I mean, this is important because if you try to do this, I mean, basically your code will just crash, because you'll get like a kind of array index out of bounds error. So yeah, that's why you only want to loop to, n-1. And then, right, each time, because they'll often ask for efficient bubbleSort, or maybe like fast bubbleSort or something. And one of the ways you can make it faster is, again, you don't have to check the last or kind of each loop, you check one less element, right? So, you know, this one is sorted, right? So we don't have to check it. So let's just go on the next one. Maybe let's choose blue or something. So here again, well, 3 is bigger than 4, right? No, so 3 stays there. Right, the next one, well, 4 and 2, so 4 is bigger, therefore we swap them. Right, 4 and 7, well, I guess 4 is smaller, so it stays the same. And then 7 and 1, well, 7 is bigger, so we swap them. And well, let's also write the 8 there as well. And yeah, let's go back to this green. Right, so now we see that, you know, these two are going to be sorted. And right, notice that when I did this comparison here of, you know, sort of 7 and 1, well, then I just stopped. Okay, like we didn't need to do this comparison between 1 and 8 because, yeah, 8 is already sorted. So I mean, hopefully you can figure out the next one. Okay, there we go. Right, the next one then, well, 3 is bigger than 2, right, so they're going to swap. Right, 3 is smaller than 4, okay, 4 is bigger than 1, so they're going to swap. And yeah, then again we stop, right, because we don't need to compare these. Right, then the next time, right, that's fine, so 2 stays the same, right, 3 swaps with 1. And then, yeah, that's fine. So, right, let me just write the 4, I guess, 7, 8. So, right, I think in this time, you know, these are going to be sorted. Right, and then in this time, yeah, these here are going to be sorted. Right, and then we just got one more, so then, well, 1 and 2, they're going to swap. Right, 3, 4, 7, 8. And then, yeah, I mean, so here, right, because, I mean, here we only did one comparison, so of course here we can just stop, right, and yeah, now it's just going to be sorted. Right, so basically we're just going to look at how we can program this. And there can also be another situation, right, I'm just going to undo a lot of this. Yeah, maybe, okay. Let's say we have the array, I don't know, like 1, 2, let's say 4 and 3. Now, I mean, here, right, let's just do this quickly. So, well, 1, 2, right, then 3 and 4, they're going to swap. Okay, so, I mean, this first time we've done. Now we just need to check one more time. So, we check these, well, 1 and 2, okay, they're correct, they didn't change. Right, then 2 and 3, okay, they also don't change. And then 3 and 4, okay, they also don't change or don't swap. So then, because these don't swap, then this means the array is already sorted. Alright, so these are actually the two optimizations. One is that, well, again, we kind of don't have to check the, well, the first time sort of 1 element, then the next time we don't have to check 2 elements, right, then 3, then 4. So there's kind of one more we don't have to check each time. Right, that's the first optimization. And the second optimization is that, well, we can check if we don't have to swap any, then it means the array is already sorted. So, you know, we don't have to then loop through again and again and again. Right? We can just stop. And of course here there's only 4 elements, so it's quite fast. But imagine having an array of 100 elements or 1,000 elements, right? If it's sorted, well, yeah, that means, you know, it's going to be a lot faster, right? Because you're not going to have to you're not going to do like 1,000 loops, basically. And I think, I mean, this is sort of going beyond the scope of IG, but basically, bubbleSort is going to be an n-squared algorithm. And what that means is that if you have, let's say 10 elements, right, then basically you're doing sort of like 100 comparisons. I mean, this is not exactly true because, you know, it's kind of n minus 1, right, but just an approximation. Whereas if you have, let's say, like 1,000 elements, well, then that's going to be 1,000 squared, right, which is what that's going to be 1,000,000. Of course, if you have 1,000,000 elements, you have 1,000,000 squared, which is going to be, what, maybe 1 trillion, I think. So yeah, I mean, basically, you know, bubbleSort is just going to kind of grow massively like this, which is why bubbleSort is actually not good. And yeah, that's why these optimizations are, you know, quite important. Right, so let's just jump back in and see how we can actually code this. Right, yeah, let's unplug. Alright, so again, let's just declare an array, let's call it numbers. And yeah, let's just go, again, let's say an array, maybe we'll go 1 until, I think 6 is okay. And then again, let's just assign these some numbers. Yeah, okay, yeah, I think they're all different. Alright, that's fine. So what we want to do then, well, we want to declare one which can be a flag. Maybe let's call it did swap, and I'm going to say that's a boolean. And then what we'll do is, well, we'll keep looping while did swap is true. So let's go did swap equals true, and then, you know, because this is a preconditional loop, let's set did swap to true. Because otherwise, if did swap is false, well then, you know, this is going to be false and it's never going to go inside this loop. Then let's just go end while. Right, and then what we can do, let's maybe declare another one. Let's call this maybe ends. I don't know, yeah, end index, or kind of the, you know, last position that we need to check. So right, I'm also going to make a constant again. Let's say num, maybe num elements. Yeah, okay. Right, so here the number of elements is going to be 6. So, right, the way this is going to start then, right, so we're going to say the end index is going to be equal to the number of elements minus 1. Because if you remember, if we've got 6 elements, we only have to loop until 5. Okay, because we're doing, well, we're comparing n with n plus 1. So that means we're comparing, you know, position 5 with position 5 plus 1, which is going to be 6. Yeah, otherwise if we're doing, well, comparing 6 and 7, well, like we see, you know, element 7 doesn't exist, right? It's going to give us a, yeah, out of bounds error. Right, so what we can do, I think in here, let's just go did swap, and this is going to be true. Yeah, I mean, yeah, I think we don't need to set it again, actually, it should be fine. Right, let's go 4, so let's say n, this can be 1, and then we'll just go to the end index. Right, again, let's go next n, just so we don't forget. And then here's where we want to do the comparison, so we just check, and then, right, let's check if, what do we call it, right, okay, nums. So, right, if nums n is greater than, and then this is going to be nums plus 1, or, well, sorry, yeah, nums n plus 1. Right, and then this means we want to swap them, right, because, for example, here, well, 6, so 6 is index n, 6 is bigger than, you know, index n plus 1, right, the next element. So then what we're going to do, let's declare a temporary variable. And in fact, hang on, sorry, so here we want to go did swap, and this will be false, right, because what we'll do is, well, if we get in here, then we set did swap to be true, right. So that means if it never goes into this kind of if condition, yeah, that means that did swap will, you know, stay false, right? And then that means we can actually just exit the loop. Right, so here let's call this temp. Let's call this what's going to be data type integer. Right, now this is something where I always kind of mess this up, to be honest. Right, so let's say temp is going to be equal to let's say nums n. Right, because if you think about this, and I'm just going to sort of draw this in Paint, to be honest. Right, let's just undo all of that. I can probably do Control A. Yeah, okay, not really. Right, hang on. Right, so let's say here we've got, let's see. Okay, right, okay, there we go, brush. Right, let's say we've got n, and n is going to be 6. Well, let's say n plus 1. I know this can be 2. And then, well, what we're going to need is we're going to need a temp. Because what I see some people doing, and, you know, this is an easy mistake. Well, for example, they'll put 6 in here, and then they think they can just, you know, swap this one here. But the problem is that, you know, when we assign 6 to this value, well, then, of course, this value now becomes 6. And, you know, then we're just going to be assigning 6 back to here. So in this case, they're both going to become 6, right? And I mean, this is why you need the temporary variable. So what we can do, we can put, let's say, put this n in the temporary variable. Then I guess we can put this 2 in this position. And then we can put this temp, you know, back in here like this, all right? Yeah, so this should work. So what we're going to do, right, the next one then, I guess we can say nums. Yeah, so do we say, right, nums n plus 1, that's going to be temp. And then I think we said nums, And again, I'm just going to refer to my diagram because it's, yeah, right, so, okay. And then we just go what nums. Yeah, hang on, I think maybe have I done that wrong? Yeah, my brain has just stopped working, to be honest. Right, so we assign this into the temporary, then we put that in there. No, I think this one should be like this. Right, and then maybe we can go temp like that. Right, okay, I think this one should be okay. I mean, right, let's test that because, yeah, probably that's wrong. Right, and then what I'm going to do, well, let's just then have a for loop just to actually output them. Right, and then here we're just going to go to the num elements, and then let's go output, and then we called it nums, right, and then just end like this. Alright, and then okay, yeah, so this seems to work. And again, I mean, you can see, right, this is pretty complex. So for me, I would say in the exam, I would probably try to draw something like this, because yeah, otherwise it's quite easy to, make a mistake. Now, I mean, if people can just, do it in their head, that's fine. But yeah, I mean, if you do need to like draw the diagram or think about it, right, yeah, like maybe that will also help you. And then I think, I mean, like here, maybe we can just count this just to actually kind of demonstrate. Let's say comparisons, and let's say, so here we're just going to count how many comparisons it actually does. And again, this is using, this is only using the one optimization so far, okay, because we also need to do this end index minus 1. So what we're going to do, yeah, like basically after we've looped through the columns, then this is going to go to the next row, right? So then we can do this end index, that's going to be end index minus 1. And right, let's say here then this will be the comparisons. So let's say comparisons plus 1, and let's just output the number of comparisons. Comparisons, alright, so this is with both optimizations. Okay, so here we see 15. Now let's make this array like kind of as unsorted as possible. So let's say this can be what, 6, 5, 4, 3, 2, 1, right? Because this is completely unsorted. Alright, so yeah, here it says we need 15 comparisons. Now let's say if it's already sorted. Right, now hopefully this should only be probably what, like 5 comparisons, because it's going to check, it's going to see that, well, I mean, did swap is going to be false, right? Because yeah, this condition is never going to be true. Therefore, yeah, this is never going to become true, which means it's not going to loop through a second time. I mean, hopefully. And yeah, here we see the comparisons is only going to be 5. And then let's also kind of ignore this end index. So this time it is always going to loop to the end. And let's also try, yeah, okay, I mean, let's also just try 6, 5. So make it kind of as unsorted as possible. Yeah, okay. I mean, I guess here, like, I guess if we wanted to make this completely inefficient, right, we would have this as another for loop. Basically, again, just looping kind of the size of the array. But yeah, I mean, let's just include this here. Alright, and then you see here, right, this is going to take 30. So, I mean, we've literally gone from a worst case of having like 30 comparisons, and that's going to be when we have kind of a completely, unsorted, right, so just like reverse order array. But then if we have this end index minus 1, well, that's going to, I mean, in this case, it's going to half it to 15. And then, yeah, obviously, if it's slightly sorted, it's going to be better as well. And yeah, I mean, this is also going to like improve the efficiency. because yeah, well, we're just going to stop once it's sorted, right? So like if we have this one, because this is sorted, it's only going to loop one time, right? Yeah, it's never going to do this kind of like while loop for a second time, basically. Right, I mean, so hopefully that makes sense with bubbleSort. I would say, you know, if you're confused about that, I mean, just practice. You know, I think as you saw, even me, right, I mean, I also forget how to do this swapping. So yeah, I think just practice this, you know, over and over again. And the good thing is that, I mean, a lot of the past papers, they often have bubbleSort, so I mean, you will get a lot of practice in that, you know, for the 15-mark questions. Right, I mean, now let's look at the final thing then, files. And to be honest, I don't actually think I've seen them ask this in one of the past papers. I think, yeah, maybe someone they mentioned they did once, although personally, I can't remember seeing that question. Maybe they've only asked it one time. But yeah, I mean, this is in the syllabus, right, so you do need to know it. So first, let's just declare, maybe call it file name. Let's call it, let's say it's going to be a string. And let's say file name, we can just call it like numbers.txt, right, because the first one we just want to write 100 random numbers to a file. And yeah, let's just maximize that. Right, so what we're going to do first, let's go open file, and then here we're going to say the file name that we want to open. And you know, here I've just made it a variable, but I mean, you could also just say, you know, numbers.txt like this. And then we just say the mode, so we say for. And then, well, basically this can either be for write or for read. Yeah, IG only has two file modes, okay, read and write. But here we want to say write, okay, because we actually want to, you know, kind of write data to the file. But yeah, I'm actually just going to use the file name variable because, well, we're going to be using this for, you know, also WRITEFILE and CLOSEFILE at the end. Right, so what I'm going to do, since we want 100 random numbers, well, let's just loop. Yeah, from 1 to 100. Let's go next n, and then what we'll do, we'll just say WRITEFILE. Right, then we want the file name we're writing to, and then we just want the value we're writing to. So I'm actually just going to round it. Okay, let's have whole numbers, and let's say this can be random. Let's say multiply by 100, and then we'll just have 0 decimal places. Right, and then we also just want to remember to close the file at the end. And I mean, they will expect you to have this close file at the end. And then yeah, so we run this. You see, we get this numbers.txt. Right, we just got 100 random numbers. Right, then let's say we actually want to read them. So yeah, maybe. Alright, I'm not going to delete it. I mean, let's just. Okay, I mean, yeah, let's just delete that part. Right, I mean, so here then we're going to use the same file. What we want to do, we want to read the numbers, get the minimum, maximum, mean, right, the number of odd and the sum, right, or the total. Because again, they always ask this, right, in those 15-mark questions, you know, yeah, min, mean, max, you know, total. So I mean, here it's basically the same. We just say open file, then for read. Now what we're going to have, let's maybe call it a line. Yeah, although actually I've just realised that we actually can't do this in IG because we don't have a way to convert to, we don't have a way to convert strings into nums, or yeah, strings into integers. So I guess, I mean, I'll just change this to the A-level syllabus. Now, I mean, they won't actually ask this in the exam. I mean, you know, right, I guess if we just want to do something they could ask, let's say maybe people. Again, I'm just going to use the football players just as an example. I can't really think of anyone else. Right, okay, let's just have those. And then what we're going to do, let's change this to people.txt. Right, and then in order to actually read a line, well, what we're then going to do, we then say read file. We say the file name we want to read, okay, then we say line. And then we just output line like this. So what this is saying, well, read file, you know, read this file, and then store that line in the variable line. So this first one, I mean, this will just say Haaland, right, the first line. And yeah, it's also saying we didn't close the file. Okay, so you see that works there. Now the problem with this is, well, we can just copy this, like 3 times, well, I guess 2 more times, and yeah, then we're going to get, Messi and Ronaldo as well. However, this works if we know like how many people are in the file. However, if we don't know, how many lines are in the file, then of course this is not really going to work, because, well, we don't know, do we need 100 of these? Do we need, 1 of them? Do we need 1,000,000? So there is actually a better way, although this is actually not included in the IG syllabus. So yeah, I think they probably won't ask you this, to be honest. But I mean, the way it is mentioned how to do it, well, we have this EOF, so this EOF means end of file. So what we can say is, well, while not end of file, right, or we could say while end of file equals false. And then here, this just takes a file name as a parameter. So what this is checking is saying, well, yeah, while it's not the end of the file, or yeah, like while there's still more content, then what we're going to do, well, then we're just going to read the file. So this is what we've done earlier. We're going to read it into line, then we're just going to output line. Right, then we're just going to go, yeah, end while like this. Again, and this should just print the same. Let's say if I also add, I don't know, let's say Fernandez. Let's say maybe like Mbappe, like that. And okay, now you see this works, right? This just reads the file and then just outputs all of them, regardless of if we have 0 lines or 1,000,000 lines. So I think that, again, that's all you actually need for IG. If we do actually try this, because it's really not that complex, what we want to do, well, we can use the num to string, which is an A-level function. But again, they wouldn't ask you how to do this in IG, but just so we can practice like calculating the min, the mean, max. Right, so let's actually, maybe let's declare, we can say like num, right, this will be the current number. And then what we're going to do, let's change this to numbers.txt, and then rather than outputting the line, well, let's say num, and then that's going to be, in fact, sorry, string to num, right, and then this here is going to be, I think we called it line, right, so that's just going to take this line, it's going to convert it from a string, convert it into an integer, and yeah, we can just test this if we want. Let's go output num. And then you see this just reads all the numbers or the lines, and converts it to an integer. Right, then what we want to do, let's go here again, let's say min, let's say max, let's say total, and also the num odd. Right, what we can do, here let's just, I guess we don't really need to assign them at the moment. Let's also say like line number, or line num, that should be fine. Right, what we'll do, let's say the line num is going to be 1. Right, we'll just start at line number 1. And then what we can do, we can say if if line num equals 1, so that, well, if it is the first line, right, then what we're going to do is we're just going to assign all of these with the kind of starting min, max, total, values. So right, min is therefore going to be num. Right, max is also going to be num. Right, then we say total. Total is also going to be. I think total we actually don't have to do in there, to be honest. Right, let's just assign this total here. We'll just give it some. Well, give it 0. Right, let's also delete that, and then what we can do, we'll just say total, like we did before, total plus num. And then what we can do, remember how we check odd, so let's go, right, if, let's go mod, and then, alright, so, this is a little bit different because, well, for A-level, mod is actually going to be a procedure. So can I go all syllabuses? Maybe this might work, maybe it won't. Right, let's try mod, and then that is going to be num. I think I said procedure. So for A-level, mod is actually going to be a keyword, right? Whereas for IG, mod is actually going to be a function. Okay, so this is going to be num, and then this is going to be 2, and then we just check if equals to 1. then here we're going to say the num odd is just going to increment, because yeah, remember if we do modulus 2 and it equals 0, that's an even number. If we do modulus 2 and it equals 1, right, that's going to be an odd number. Right, so num odd plus 1, and then we'll just go end if like this. Right, so then we just want an else, right, because we want to say, well, if the line number is not equal to 1, right, here's where we actually want to check, check the min and max properly. So we're going to say, right, if num is less than the min, right, then we're going to say that min is going to be equal to num. Right, then the next one is going to be if num is greater than max. Yeah, then we're just going to set the max to be equal to the current num. And I mean, yeah, hopefully this makes sense, because again, what we're saying is, well, so line 1 is 56. So here, if line number 1 is 56, well, then we say, yeah, 56 is the minimum, 56 is also the maximum, because, you know, it's the first number. Right, then when we loop the second time, and, you know, we will actually have to increment this line num. Right, so line num plus 1. Now, honestly, you know, we could make this a boolean. We could call it like first, yeah, maybe first num, or sorry, first line. And we say, yeah, if first line equals true, and then here we just set first line to false, right? That's also, you know, the same. But all right, so anyway, the next time, so the second line here, well, that's going to go into this else block. So then, well, num here is going to be 63. So if 63 is less than the minimum, well, that's false, right? So it's not going to do that. But here, if 63 is bigger than the maximum, so if 63 is bigger than 56, which is true, well, then it's going to set 63, and it's going to put 63 as, you know, the new maximum, or it's going to assign 63 to be the new maximum. Yeah, so I think that's fine for the min and max. Then we just want total, and let's also set the num odd as well. Just assign this to be 0. Right, and again, let's just output this. Let's go min, and yeah, hopefully there's no mistakes. Alright, then we'll just go max. Right, then let's go mean. Or in fact, yeah, we have the total, right? Let's go sum. That can be the total. Output, again, we're going to go mean. I think this time, let's not round it. Let's just have, you know, the full number. So that can be total divided by... and alright, so I guess here we actually do need the line number, because, yeah, we need to, you know what to divide it by. Right. And I think here, let's actually start this at 0. Because otherwise, for example, if we only have one line, well, line number would start at 1, right? But then it's going to go line num plus 1, so it's going to go to 2. So then we would have, you know, total divided by 2. But yeah, you know, we don't want that, right? We want to have the correct line num in order to calculate the mean correctly. Right, so I think that should work. And then let's also get output. Okay, hang on. Output, let's say odd. That can be, was it num odd? Let's also output even. So our even is just going to be the line num, so this is the number, right, minus number of odd. And yeah, I think this should work. Okay, yeah, so it seems it doesn't like that. Because I guess, yeah, alright, so what I'm going to do, I mean, I'm just going to use the A-level version. So the A-level function, the A-level version is just going to be a keyword. However, right, if you are doing IG, again, it should be a function. So IG, it should be like this. However, the reason I can't do that is because, well, this string to num, right, this is only a, you know, A-level function. That's why I need to put the syllabus on, yeah, the A-level mode. Alright, but if we run this, yeah, and I mean, this seems to work. So the minimum is 0. I guess there should be a 0 there somewhere. Okay, yeah, so we see 0 here. The maximum 99, I mean, yeah, there's a 99. Right, probably there's not a 100. I mean, the sum, yeah, probably that's correct. I mean, the mean, well, that's correct. And then, yeah, I guess odd, even, right, they also seem to be correct. Alright guys, so, I mean, well, initially I planned only 60 minutes or 90 minutes. I mean, probably now it's gone like over 2 hours. So yeah, kind of a lot longer than I expected. But again, I mean, that's the whole syllabus, right? Everything you need to know. And I'd say if you know this, of course, just practice the 15-mark questions, and yeah, you should be fine. Now, I will actually make videos covering all of the 15-mark questions, and yeah, hopefully I'll kind of start uploading those in the next few days. So if that's something you're interested in, all right, then also make sure to check those. All right, so yeah, hope to see you in the next video. All right, see you.